This 8-hour course will teach you the fundamentals of Node.js and Express, so you can start creating back-end and full-stack web apps using JavaScript. This course was created by John Smilga. John has created a bunch of courses, including many of the more popular courses on the Free Code Camp YouTube channel. John's teaching is very hands-on, so you will create a bunch of projects while you're learning.
What's up, everybody? This is John from Coding Addict, and welcome to Node and Express tutorial video, where we'll cover fundamental building blocks of Node and Express.js framework. Now, since I want everyone to be on the same page, we'll start the series with Node and Express fundamentals and gradually move to more complex topics. We will build complex REST API with Express.js as well as full-blown MERN application. In this comprehensive Node.js course, you will not only learn fundamentals of Node, but also many related technologies like Express.js framework, MongoDB, as well as Mongoose. The main goal of the course is to show you how to build modern, fast, and scalable server-side web applications with Node. Like in all my other courses, to solidify our knowledge, we'll build a bunch of cool apps and go through the steps of deployment as well. Lastly, let me just say this. If you're like me and you enjoy learning new tech by building projects instead of going through the slides, you will enjoy this course. All right, and let's start by answering the most obvious question first. What is Node.js? And even though there are plenty of good answers out there, the one that I like the most is this one. Node.js is an environment to run JavaScript outside of the browser. Node.js was created in 2009, and it's built on top of Chrome's V8 JavaScript engine. As you probably are aware of, every browser has an engine, a tool that compiles our code down to machine code, and Chrome uses one by the name of V8. In extremely simple terms, the creator of Node, Ryan Dahl, ripped out the V8 engine and built Node on top of it. Since the moment it was created, Node has evolved tremendously. And while there are many things to like about Node, I particularly enjoy large community around Node, since that tremendously saves time on feature development, as well as the fact that with the help of Node, it's never been easier to build full stack apps, since both front-end and back-end are essentially built in the same language. And you guessed it, that language is our beloved JavaScript. As far as course requirements go, there are not that many. My expectation is that you are familiar with basic HTML elements, simple CSS rules, and have general understanding of JavaScript, especially ES6, callbacks, promises, and async await. Since this is a Node course, and I already have tremendous amount of Node content to cover, I'm not going to spend too much time on JavaScript language fundamentals. While you can still follow along with the course without knowing basics, it's crucial if you want to understand how stuff works behind the scenes. As a side note, if you need to brush up on the JavaScript fundamentals, I have a YouTube channel called Coding Addict, where I post a bunch of cool JavaScript related content. Specifically, you might be interested in JS Nuggets playlist, where I cover a bunch of useful ES6 features, as well as asynchronous JavaScript topics. So if you need to jog your memory on JavaScript fundamentals, I suggest going to YouTube, look for the channel by the name of Coding Addict, and then more specifically, the playlist by the name of JavaScript Nuggets. When it comes to course structure, it goes something like this. In the first section, we'll get familiar with Node.js, as well as my dev setup. In the second section, we're going to install Node.js and quickly cover some general differences between browser.js and Node.js. Then we'll spend some time on Node.js fundamentals in section 3. And after that, we'll learn what is Express.js in section number 4. And once we're done with Node and Express fundamentals, so once we're done with pleasantries, then we're off to the races, where effectively in every section after that, we will build a bunch of cool Node.js apps. All right. And before we install Node, let's quickly cover some major differences between browser JavaScript and Node.js. So essentially how Node.js apps are different from the browser JavaScript apps. And let's start with the biggest one. When working on Node.js app, you have no access, let me repeat, no access to browser APIs. Since, well, they don't simply exist in Node. There is no browser. So there's no DOM, there's no geolocation, no fetch, and all the other cool browser goodies. You see, unlike browser apps that are interactive, for example, user clicks the button or toggles the nav and that sort of thing, with Node, we build server-side apps. And I know it's hard to picture that right now, but our Node apps will only consist of pure logic without the graphical interface. On that note, you know how in browser apps, we use a bunch of cool things available on the window object. Yeah, sorry to break it to you, but that's also not available in Node. So at no point in the course we'll write document.querySelector. All right. And once we have covered things that Node.js does not have, let's switch gears and see some of the goodies that Node has to offer. For example, unlike browser, we can access file system, info about our operating system, respond to network requests, just to name a few. Also, another major benefit of Node is the fact that it's based on versions. So unlike browser apps, which depend on the user's browser, our Node app depends only on Node.js version it was built in. So in other words, if we build a browser app, and if our user's browser does not support a specific feature, it is our responsibility to fix it. Otherwise, our app might have bugs, correct? But when we're done building our Node app, there's no rule that we have to upgrade to a newer Node.js version and possibly break our app. We simply can keep running our Node app in the version it was built in and without any worries go on about our day. Lastly, unlike browsers where modules are optional, in Node.js you have access to modules by default. And it's hard to imagine a Node app where you're not going to use them. As a quick side note, under the hood, Node.js uses CommonJS library for the modules. And while the general idea is exactly the same as for the ES6 modules that we use in the browser, syntax is a bit different. As far as the install, it's as straightforward as it gets. Just navigate to nodejs.org, pick a LTS version, answer yes to all the questions, and if you don't get some weird bugs, congrats, you have installed Node. In order to check if everything went correct, just type node -- version in your terminal and you should see the version number. If you don't, you'll have to troubleshoot the error. Now, as much as I would like to help, when it comes to install, it's impossible for me to troubleshoot your local setup. So when it comes to troubleshooting install errors, I strongly suggest using your favorite search engine instead. Typically, within a matter of minutes, you'll see a bunch of useful solutions to your exact problem. Lastly, let's also talk about versions. As you can see, at the time of the recording, I have two options, 14 LTS or 15 current one. If you read the Node docs, you'll see that for production apps, they always suggest using LTS, which stands for long-term support. And therefore, I will also suggest the same, but as far as tutorial, I don't think you'll have any issues if you use the current version instead. Now, also, since you're watching this in the future, your version number most likely is going to be greater than 14, basically greater than mine. I definitely suggest installing the LTS option that's offered to you instead of downgrading to my version. And if you're stressing about content being out of date, let me assure you that everything we cover in the course will work perfectly fine with your current Node version. And eventually, if some bugs do creep in, I will definitely update the course content. So long story short, just install your current LTS version, whatever it is, and you'll be in good shape. So in my case, it is 14. I have two big buttons. And of course, since I would want to go with LTS, I'll click on the left one. Then notice we are getting the download package. And now I just need to go to my downloads and then crack it open. And then, like I said, we just need to answer yes to all the questions. So we go with continue, continue, and yep, I would agree. And again, we just install, and then we'll be prompted for our password. And once we add that one, we should be in good shape. And then, like I said, once the install is complete, and yep, we'll move this sucker to the trash. Then if we go to our terminal, and if I massively zoom in, and if I type node dash version, there it is. I should have my version number, which in my case, of course, is 14. If you also can see the node version in your terminal, you are in good shape and you can continue with the videos. If not, please troubleshoot it, because otherwise everything we're about to do next is not going to work since you haven't installed Node on your computer. Install is complete. Hopefully we all have Node on our machines. Now what? What do we do? For contrast with vanilla.js, it was somewhat easy, right? We create index.html, jam our JavaScript code, whichever way we prefer, and browser does the rest. It evaluates our JavaScript code. But what about Node? How do we get Node to evaluate our code? And effectively, we have two options. A REPL, which stands for read, eval, print loop, and CLI executable, which just means running our app code in Node. If I have to be perfectly honest, REPL is for playing around, and CLI is essentially for everything else. In fact, this is going to be the first and most likely the only time we'll use a REPL in this course. And after that, CLI is going to be our best friend. How do we spin up the REPL? Well, we go to terminal, and in terminal, we simply type node, and then no arguments, nothing. We just press return or enter, however you would like to call the button, and that's it. Now notice we have this little angle bracket. That just means that we are in a REPL. And once we are in a REPL, we can do REPL things. What would be a first REPL thing we can do? Well, we can simply type our name. So const, and the name is equal to John. And there it is. Of course, now I can access name, and my name is John. As you can see, you're not going to write anything serious in here. And if you have written any vanilla JavaScript apps, you know that, of course, we can also do the same thing in a browser console. So we can also evaluate some code there, but of course, we're not going to write anything serious in a browser's console. So the same thing is for REPL. Yes, we can come here, we can play around. But when it comes to serious applications, of course, you'll pick a CLI executable instead. And in order to close the REPL, we simply go with Control and C. And as you can see, we have a suggestion that we need to press it again. And now, of course, we're out of the REPL. Not bad, not bad. We now know how the REPL works. But what about a more serious Node application? How do we get Node to evaluate our code? Well, we would need to start by creating a project, right? So back on my desktop, I'm going to create a new folder, and surprise, surprise, I will call this tutorial. Why? Well, because we'll do tutorially things. And I'm going to say tutorial. Now, of course, if you want, you can add Node, but I'm just going to leave it as a tutorial. And then, of course, we'll have to use our text editor. In my case, like I already previously mentioned, I'm using Visual Studio Code, and my preferred method is just drag and drop. And then inside of the folder, what I would want is to create a new file. And this is the case where you can literally name it whatever you would want. And in my case, I'm going to go with app and JS. And in this app.js, again, I would want to write some more serious Node program. And the program is going to be following where there is a const. So there's a variable by the name of amount. And as a side note, I'll make this bigger, and I'll probably bump up the font size just so we can see a bit clearer. So we're going to go with const, and you know what? I'll also close the sidebar. Hopefully you see that I have the file by the name of app.js. And like I previously mentioned, we're going to have a variable by the name of amount, and it's going to be equal to 12. And now let's set up a if condition where if amount is less than 10, then we simply console log small number, and otherwise we'll just say that the number is large. So we go with if, and we're looking for amount is less than 10. And if that is the case, we go with console log, and we'll just say small number. And otherwise, if it is, of course, equal or bigger than 10, then we go with console log and we say large number. And at the end of the day, we just write console log, hey, it's my first node app. As you can see, an extremely complicated functionality. And in this case, I'm just going to set up the template strings so you understand that, of course, we can use them here as well. I'll say, hey, it's my first node app. And if you want, of course, you can jam the hello world there somewhere as well, because that is the traditional approach with the first program. And then in order to execute this code, we effectively have two options. I can navigate back to my terminal and I can zoom in like so. And of course, now I'm in a root, so I would need to navigate to the desktop. And probably the fastest way is just typing cd and drag and drop my folder here. Okay, so now here, as you can see, I'm in the tutorial. And in order to execute my code, I just need to type node and then app.js. Now, keep in mind that technically I could have done that from the root. I would just need to provide the full path where I go to users, blah, 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 and then tutorial. And of course, the file name is app.js. And let me bump up the font size even more. And the moment we run it, check it out. We have a large number. And hey, it's my first node app. Now, if you don't believe me, we can go back and we, for example, can say that the number is 9. And of course, again, we would need to run the code. And we're going to go with node and then app.js. Beautiful. We have small number and we still have our, hey, it's my first node app. Again, the whole point of this line here is just to showcase that not only we can use quotation marks, but also we can use the template string as well. So that's one option. But if you're familiar with VS Code, you know that it has this cool feature of integrated terminal, where effectively we have our terminal, but it is right away pointing to our folder. So we don't need to do this whole dance where we navigate to the folder and then run the app. We simply can open this up, and the shortcut is Control and tilde. And also keep in mind that, of course, you can navigate through the tabs. The problem is that I always forget where it is. And effectively, we need to go to View, and then you're looking for this terminal command here. As you can see, this would be a shortcut, Control and tilde. And in here, we have a nice suggestion that we are already located in tutorial folder. And what do we need to do? Well, again, we just go with node app.js. Why? Well, because that is my file name. So for the remainder of the course, I'll use the integrated terminal that comes with VS Code. Just understand that both of them effectively do the same thing. And there it is. Now I run node app.js because that, of course, is the file name. And I have small number and hey, it's my first node app. And that's how we can evaluate a more serious code using Node. As a note, if at any point during the course you need to compare your code to mine, just navigate to website johnsmilga.com. Again, the website is johnsmilga.com. And then either in the project page or in the homepage, you'll find Node Express tutorial project. So in the homepage, you'll find it in the latest project. So just keep on scrolling. But if it's not here, it's definitely going to be in the projects page. And you can even filter it in order to save some time. So look for Node in here. Like I said, the project name is Node Express tutorial. And that any of these links will get you to the repo. And at this point, you can either clone it, fork it, or just simply download, and you're looking for this Node tutorial. And in here, you'll find all the folders as well as the files. Now, keep in mind that eventually, when we start working on Express, we'll have to get this repo anyway, because I'll use it for a starter since I have prepared some assets for you, some assets that we're going to use in our examples. So this is really up to you. If you want, you can get it right now. Just keep in mind that you'll have to get it later anyway. And once we have executed our first code in Node, let's quickly cover the concept of globals or global variables in Node. And the emphasis is on the word quickly. Yes, there are more global variables available, but the idea is not to spend half an hour in Slideville. Instead, I would want to give you a general idea. And as we progress with the course, don't worry, we will implement them. And that way you can right away see them in action, not just some random general description. And before we continue, let me just mention that throughout the tutorial, the code from the previous video, I'm going to save in a file. So for example, remember our first complex app with amount and all that. So what I did, I created a file name by the one hyphen intro.js, and then I just copy and paste it. And this is what I'm going to do throughout the Node tutorial part of the course. So that way you can always have access to the code. And if you ever need to, you can jog your memory. Now, if you don't want to use my one, if you're adding your own comments and all that, I would also suggest doing that. Where essentially just create a file, just dump it, and then that way you are slowly progressing on the course. And if you ever need to go back and refresh your memory, you always have that option. And keep in mind that if you would want to run this file, you simply go with node and then whatever the file name, right? So in my case, that would be 1-intro.js. Again, I'm going to keep on numbering them because I'm just annoying that way, but you don't have to. That is really up to you. So back to the globals. When we work in vanilla JS applications, we know a very cool thing is the fact that we have access to the window object. And the reason why it's so cool, because in the window object, we can get a bunch of useful things, right? So for example, we can get a query selector. So I can select a node. I can get built-in fetch, and hopefully you get the gist. Now, I don't want to rain on your parade, but in Node, there's no window. Why? Well, because there's no browser. So there's no window object. So if you'll try to access window, Node will spit back the error, and most likely your app will crash. Now, there are some globals, of course. There is this concept of global variables. And essentially, what global variables means that anywhere in your application, you can access them. So no matter how complex my application gets, how nested it gets, or whatever, I'll always have access to those variables. And again, let me repeat, these are just some of the variables. Of course, there's more. And I'm not going to spend hours and hours talking about them. I simply want to give you a general idea. And then, like I said, we'll start using them and you'll see them in action. And in my opinion, that's just going to make it way clearer about what, in fact, they're doing. And some of the useful ones, we have their name. So that would be __ their name. Just going to give us path to current directory. Then we have also __ file name, which, as you can see, is going to give us a file name. Then we have require, which is a function to use modules, as well as the module that would be info about the current module. Now, these two, we'll literally cover them in the upcoming videos because our next big topic is going to be modules. So for the time being, just remember that we have require and module, and you'll see them in action in no time. And then we have a very, very, very useful one. And that one is a process. And why it's so useful? Because it gives us a info about the environment where the program is executed. Because we need to keep in mind, when it comes to a Node app, at the moment, yeah, we're executing that on our machines. But when you deploy, for example, your API, so for example, your server, right? Where is it sitting? It is sitting on DigitalOcean or Heroku or whatever. So that, of course, is already a different environment. And of course, based on that environment, you can make a bunch of decisions in your application. Again, if you'll take a look at the process right now, it's just going to be a giant object of gibberish data. But trust me, as we're progressing with the course, we'll find a bunch of useful properties that we'll implement in our application. Now, any of them, you can simply console log and you'll get that useful data. So you can just run console log and then, for example, their name. Again, I'm not going to console log all of them. Probably the biggest one is going to be the process. Like I said, you'll get a bunch of properties that at the moment will look like gibberish. And I simply need to save. And of course, then we go with node and app.js. We run that and there it is. Now, of course, this gives me the path. So if you're interested, of course, you can console log the rest of them as well. But in my case, I'm going to stop with their name. Now, also very quickly, yes, you have access to the console. So as you can see, in order to console log, we had to use the console. So that is also something that is available globally. Then just like in the vanilla.js, we have set interval as well as set timeout. So you can run these ones. And I'm not going to run both of them, but I'll show you set interval very quickly, just so you don't think that I'm cheating. And the way it's going to look like, of course, we have our callback function. And then I'll say that my interval is going to run every second. And I must type hello world. Otherwise, well, what kind of tutorial is this? And again, we simply go back to node and then app.js. And as you can see, now after every second, I have hello world in console. And in order to stop it, remember the command was Control and C. And before we move on and start talking about the modules, let me also mention something else, where essentially we don't need to type node and then app.js. You can simply write node and then app. However, throughout the course, I'll probably keep on typing JS just because I'm annoying. That would be the first thing. Now, the second thing, and this is not a node thing, this is actually a terminal. If you don't want to type it, you can simply go back to the previous command. And in order to do that, you need to press on arrow key up and check it out. The moment you press, notice that was my previous command, and then I have one before that. So in my case, that is node and then app.js. Again, you don't need to add that JS extension, but probably I will. And then you just go back to the previous command and then press, and again, you just execute that command. And of course, if you would want to clear the console, again, this is not a node thing, this is a terminal. I just type clear. And lastly, to answer the question that's probably bugging you the most, do we always have to just type node and then the file name? Because as we're going to be testing, especially in tutorial, it will probably get annoying. And the answer is yes, but only for now. Once we learn about NPM, the external packages, which at the moment I fully understand doesn't make any sense at all, then there's command that effectively will restart our application. So we'll have to install some third-party module, some external library, and that will do the job of restarting the application. For now, yes, all throughout tutorial, up until the point where we cover that external library and external libraries in general, yes, we'll have to type node and then whatever is the file name. I know it's a little bit annoying, but I just don't want to skip ahead. I want to get us there with a full information of what is happening. So with this in place, with clear understanding of the global variables in Node, now let's move on to our next topic, which is going to be modules in Node. Beautiful. And once we understand the globals in Node, now let's talk about the modules. And first, let's return to this command. Notice we have here node and then app.js. And probably the question that you have is, well, does that mean that all my application needs to be in this one file? And the answer again is yes and no. Yes, you'll execute one file, but you'll split your code in modules. Otherwise, that would be literally insane to jam all your code in one file. And effectively, I'll just show you with an extremely complex app. And of course, extremely complex is in the air quotes right now. And you'll see why we'd want to use the modules in the first place. So in the next video, I'll give you official intro with a bunch of gibberish and all that. But for the time being, let's just build super complex app and then see why we would want to use those modules in the first place. And if you have any familiarity with ES6 modules, if you have worked with them in Vanilla.js or in React.js, you're already in good shape. The syntax is going to be tiny bit different because Node uses common.js, but the general idea is exactly the same. And we start with a simple function by the name of say hi, you guessed it. And then this function is going to be looking for the name parameter. And then inside of the function, what do? We simply console log and we say hello there. And then whatever is the name of the dude or the gal that is being passed in as a parameter. And of course, we can invoke it and I can say hi, and then pass in Susan, for example. And in order to make this interesting, I'll set up some variables as well. So I'm going to say const John is equal to John. And you guessed it, since there's a John, there also has to be a Peter. And hopefully you get the gist. So imagine we would have a bunch of names, and then we have probably more functions than this one, but for the time being, this is just going to be say hi. We copy and paste. We invoke this function, I guess, 3 times. One for Johnny boy, one for Peter, and then the first one we already have for Susan. And what do? We run node app or app.js. We run that, and there it is. Now, of course, in our console, we can clearly see hello there, Susan, blah, blah, blah. Now, wouldn't it make sense if the names would be separate as well as this function or the future functions that we're going to create would be in separate files, and then we can access them all throughout the application. And that way, of course, we would have smaller files and more structure to our application. And that is exactly what the modules allow us to do. And that's why we'll move on and start talking about the modules in the next video. Beautiful. And once we understand the main problem with this code, where again, the moment code is technically still tiny, but as you can see, it is getting bigger and more annoying with every line. Now let's talk about the modules. And I guess let me just give you the main idea first, and then we'll talk about the implementations and all that good stuff. So first of all, what are the modules? Again, if you're familiar with ES6 modules, you already have the idea, but essentially that is encapsulated code. And the key here is that we're only sharing what we want. So we're only sharing minimum. How would that look like in real life? Well, I can go here with secret, and then I can type here super secret. And then since this variable is in this file, as we can see, you can access it anywhere. Okay, so by mistake, I can just access it. I can override it. Now, of course, you can make an argument that, I mean, it is made with const, but hopefully you get the gist. This is available to me everywhere in this file. So once we set up the module, you'll see what are the differences. Now, Node uses common.js library under the hood. That's what makes it happen. And then every file in Node is a module. Again, let me repeat, every file in Node is a module. So those superpowers that we will cover in just a few seconds, we have them by default. We don't need to do anything. We don't need to go to the store and buy some JavaScript code. No, we just get them by default. And the way the modules work, well, we simply need to create a new file, right? And I'll right away set up the names here because, of course, eventually this code will be sitting in the file name by the 3 hyphen and then the module basics or whatever. But the names as well as the function, well, it's going to be in a separate file. So what I'm trying to say is that in a root, of course, there's no folders or nothing, so everything is root. I'm going to go with 4. And again, I'm doing that because eventually this is going to be 3 hyphen module something. I'm going to go with maybe names, or you can type first module, whatever you would want. And I'm just going to go with names.js. Okay, awesome. And then I'll take these 3 variables from my app.js and I'll copy and paste in the names. And then also what I would want is to set up one more file. And of course, this one will be 5. And I don't know, we can say second module, or so I'll say here utils, something generic. So we set that up. And now, of course, what I would want is to grab this function from the app.js and copy and paste in the utils. And now, $64,000 question. Is this app going to work, or is it going to break? And of course, the answer is it's going to break because we have no access right now to say hi or to John or Peter. So why don't we go to the names and console log something? And as a side note, yes, you can console log this in the app.js. It is a file, so by default, it is in a module. But since we'll do most of our work in the names and utils first, why don't we go to names, and that way we can also see how we can run the file just by using a node. And what I would want your console log is the global by the name of module. So in the names, go below or above the variables, doesn't really matter, and go with console log and then module. And remember to run node and then whatever is the file name. So in my case, it is 4 dash and then names.js. You run this and you'll notice something pretty cool, where we have the object, and in that object we have quite a few properties. Now the one that I'm interested in the most is this exports one, and it tells me that this exports is an object. And the way the common JS syntax works, whatever I'm going to dump in that export, I'm going to be able to access anywhere in the application. So that's the key. Remember, we're only sharing the minimum. So it's up to us to set those values in that exports object. We decide what goes in there. Previously, remember, secret was accessible everywhere in my app.js. Now in the names, I can be, hey, you know what? John and Peter, yeah, I'm sharing them. Anywhere in the application, we can access that. But the secret variable, no, this is just going to be local. So I'm going to add here, I guess, the comment by the name of local. And that way, at least we understand. So this is going to be, I'm not going to use global, but I'm just going to say that share. So we're sharing this with the rest of our application. And then if I know that this is a object and it is sitting in the module, how does that work? Well, we go with module, then it is an object. So we go with export, and we have multiple ways how we can set this up. But the most basic one will simply say that, yep, it is an object. And inside of that object, there's going to be 2 properties, John and Peter. Now I can probably already guess that we're using a ES6 syntax. Since the key name is exactly the same as the value, well, we can simply pass it, right? So we have John and Peter. So now what happens in the app.js, we can access them. So I can go back, and this is the case where we'll need to run that require. Remember in the globals, we talked about this function. So in order to share them, we need to use module.exports. And essentially, I'm setting up the object like so, where I go with whatever values I would like to share. Now, in order to access them, I need to go with require, and I can assign it to a variable, or I can simply require. Now, in our case, we will assign it to the variable, and I'll use the same type of syntax where I'm going to go with names, just so we can console log that. And this is going to be equal to a require. So that's my function. And as a parameter, we need to pass in where the module is located. So where is this data coming from? And always, 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 you will be setting up your own module. You have to start with dot. Now, sometimes your modules will be 2 levels up, I don't know, 3 levels up, whatever. Then, of course, you'll start with dot dot. But you'll always start with this one dot because there's also going to be a third-party modules and there's going to be built-in modules in Node. And then we'll use just these quotation marks. Again, super, super important. Every time you create your own module, you'll have to start with dot and then /. So essentially, you're giving a path. Now, in our case, what is the path? Well, I'm looking for the names, right? So I set up here the path. And then if I console log the names, I should see something pretty cool where I go with names. And there it is. Now I'm going to run node and then app.js. Now, keep in mind, we're not running names anymore. We go with node and app.js. Now, of course, it still complains that we have no access to high. Let me comment this one out. So let's say node and app.js and check it out. Now, of course, we have the object with John and Peter. And we explicitly said what we would want to export. So we go with exports. And that way, no one has access to the secret one. So this secret one is only for this file. And of course, we can do the same thing in the utils as well, right? So we have the say hi, and we go with module and exports, and I can just simply set it equal to. Now, the reason why I was setting this up as a object, because I had multiple things. I had John and Peter. And don't worry, in the next video, I'll show you alternative syntax, how you can also set this up. But in this case, I have object, and then, of course, I'm setting these properties. And as a side note, this is just my preferred way of actually using the exports. Again, there's multiple ways how we can do that, and I will cover the other ways in next video. But this is just my preferred method. That's why I right away set my exports equal to an object and then pass these 2 properties. And in the utils, since I only have one thing, I'm just going to go with say hi. That's it. I'm saying that I'm going to be exporting my function. So say hi, like so. And once I have exported my function, now, of course, I need to go back to the app.js, import my function, the same name. And I'm going to go with say hi. And that one is going to be coming from the different file, of course. So we go with 5 and then utils. Notice here how we don't need to pass in the JS. If it is a JS file, we just simply omit the extension as long as the file name, of course, matches. And then I can remove. Now, if you want, you can console log, but I already know that I'm going to have the function over there. I'll uncomment my say hi. So now, of course, there's going to be no error. And let me clear the console. And again, we run the node and then app.js. And there it is. Now, of course, we have a different error where it says, well, John is not defined. All right. But I know that John is sitting in the names, right? So here we have multiple flavors. Either you can destructure it. So instead of going with names, I can go John and Peter. That is definitely one option. Or I can go with property names, right? So I can say names and then John. And then the second one is names and Peter. Names and Peter. And now hopefully everything works. Otherwise, you're probably thinking that I'm just messing with you. There it is. Now we have hello there, Susan, John, and Peter. And effectively what we did, we separated our concerns. Again, the main idea is that every file by default is a module. And then when it comes to a modules, we are in charge what we are sharing. And in order to export or make it something available from this module, we go with module exports. And then we just set up the functionality, whether this is going to be a object that we're exporting or we're simply exporting as a function. So we set this equal to the exports. And if you're familiar with ES6 modules, As you can see, this is very familiar to the export default and then whatever you're exporting as default, whether that is a function, whether that is a React component or whatever. Notice I'm exporting as default. So of course, when I'm importing this, in this case, app.js, well, I already know that this is a function. So I can name this whatever I would want. And the same goes here. Since I'm exporting this as object, I can call this shake and bake. As long as I access it later, of course, I'll be able to access the property as long as the name matches to whatever I set up over here. So let me save this. And now, of course, we can talk about our next topic. All right. So far, we know two flavors. One, if we want to export one value, we just set module exports equal to that value. And then, of course, wherever we want to use it, we just import it, set it equal to some kind of variable. And of course, once we use that variable, we have access to that value. And the second flavor is if we have multiple values, then we simply set module exports equal to an object. And then in that object, we set up the properties. However, there's also another way how we can do that. And essentially, it is called export as you go. And the way it looks like, first, I'm going to set up a new file and I'll call this 6 and I'll call this alternative flavor. Now, again, naming is really up to you since that is the hardest thing in programming. And then I'm going to come up with one array and I'm going to call this items and that will be equal to item 1 and item number 2. And then I'll set up a object and I'll say const person is equal to a object. And in there, surprise, surprise, we'll go with name property and set it equal to Bob. And I'm purposely adding multiple data types just so you don't think that we can only export variables or functions. And in here, we have two options. Either where we are setting up the value, in this case, items, I simply go with module exports and then whatever is the name. And of course, in this case, I'm going to keep the items. But notice the syntax where instead of going with const items, I right away go with module.exports. Or if you are a true rebel, you can do something like this. Module exports, set up the property, for example, single person, and set it equal to your person object. Why we're able to do that? Because if you remember in the previous video, when we console logged module exports, it was an object, right? So what are we doing here? We're setting up a property on that object and set it equal to an array. And here I set up another property and just set it equal to a person. Keep in mind, of course, I can still write simply module exports and then the person. But since you might sometimes see this type of syntax as well, I wanted to cover that. And now, of course, we save alternative flavor JS. And you're probably not going to be surprised that if we navigate to app.js, and in this case, I will call this data because I'm getting a object, and on that object, I have two properties, and I need to come up with some kind of name. Now, as always, this name is really up to you. You can call it shake and bake. You can call it Uncle Bobby, whatever you'd want. In my case, I'm going to go with generic data. We go with require. Again, we're looking for the file by the name of alternative flavor. And in this case, I'm not going to do anything with it apart from console logging. And if I navigate back to my integrated terminal, again, run the node app.js, there it is. Of course, now I have the items as well as the single person. Now, please keep in mind one thing, where this syntax, whether the first line or line number 6, at the end of the day, that's exactly the same like we're doing over here. Yes, the syntax is a bit different, but at the end of the day, you just make these values available somewhere else in your code. Now, just because I prefer this type of syntax, most likely throughout the course, you'll see this approach. But if you prefer this one instead, be my guest. At the end of the day, it is your application and you're the one who is going to be maintaining it. And before we move on to built-in modules as well as third-party modules, let me throw you a mind grenade. And I'm going to start by removing this console log in the app.js, like so. And I'm going to create a new file with the same exact name, a mind grenade. As always, if you would like to call this differently, that's totally your option. And I'm going to go with mind grenade, like so, and JS. And in this file, I'll create some basic functionality. And by the way, let me save app.js. So let's go with const num1 is equal to 5, and then const num2 is equal to 10. Of course, there has to be a function that adds these values, as always with every tutorial. So we'll go with add values. Just for the sake of it, I'm just going to go with good old function keyword and the old setup, meaning not the arrow function syntax. And simply here, we'll go with template string, the sum is colon. And then, of course, let's go for template literal. And we'll say num1 plus num2. And instead of setting up the exports, I'll simply invoke add values. And now I'll throw you that mind grenade that I was talking about, where in the app.js, I'm not going to assign it to anything. I'll simply write require, and then we'll go with mind grenade. And now let me comment out these three, since at the moment they'll just overpopulate the console. And again, let's run node and app.js. And once we run our code, we can clearly see in the console something pretty interesting where we have a log of the sum is 15. So what's happening over here? Well, when we are setting up everything, if we have a function inside of the module that we invoke, yes, that code will run, even though we didn't assign it to a variable, as you can see clearly here, and we didn't invoke that variable. And before we go any further, let me mention three things. First, it's not unique. You can also do that in ES6 modules. And if you took my vanilla JavaScript course, you know that we use that functionality. Number two, yes, throughout the course here and there, we will use this particular setup. Now, it's going to be with third-party modules. And of course, once we get there, I will remind you about this setup. So that's how it works. And third, I wouldn't suggest losing your sleep over it. Just please remember that when you import a module, you actually invoke it. And this is really going into weeds, but the reason why that happens is because this code is not just exported on its own. When the node exports this, it actually wraps it in the function. So that's why when you require it, yeah, you do invoke the code if you have some kind of function that actually is executed here. Keep that in mind. I'm not talking about exporting something. I'm talking about executing function here and there. And of course, in this case, you need to use the imagination that we'll do something way more useful than this. At this point, you're looking at it, okay, I could have just set up that function in the app.js, and you're 100% correct. This is the place where you definitely need to use your imagination, where, of course, the functionality we'll use it for is going to be way more complex. But the idea is going to be similar, where we'll just require some kind of module, and behind the scenes, that module will do a bunch of cool stuff. Okay, that was fun. We created our first module, and in the process covered the general module syntax and use cases as well. Now what? Well, as helpful as our say hi function is, some very smart people created way more useful modules than that. And the good news is that we can start using them right away. So what I'm trying to say here is that Node has a bunch of built-in modules that we can use freely in our apps. In the following videos, we're going to cover following modules: OS module, so operating system module, path module, file system module, as well as HTTP module to set up our HTTP server. And before we continue, let me just say this. I purposely cover only few major modules, and more specifically, only few properties. and methods provided by those modules. You see, the list of built-in modules in Node is quite big, and the amount of properties and methods each module has combined is, of course, even bigger. And as a result, we could easily spend the remainder of the course on just that. But is that really beneficial? And of course, the answer is no. Instead, let's cover the general setup first, and later, as we progress with the course, implement some modules as we go. Now, if you're interested in more properties and methods built in modules have, just navigate to the docs and go nuts. So if at any point you would want to find out more about specific property or method or the built-in module in general, just navigate to nodejs.org and then look for the docs. And again, in my case, the version, the long-term support version is 14. So I'm going to click here, but as you can see, we also have an option of going to the older versions as well. So as you can see, I can get the docs for the older versions as well, but I'm just going to stick with my version and then be prepared to go nuts. If you enjoy docs, then you'll have yourself a big old party where, of course, you can look for modules, and then each module has the properties as well as the methods. So, of course, you can get a extremely detailed information on the properties as well as the methods here in the docs. All right, and once we have covered the general existence of built-in modules, now let's take a look at a few of them. And I'm going to start by creating that file that I promised a few videos ago. Remember when I was setting up the modules, I said that eventually there's going to be a file by the name of 3N modules. And this one, I would want to do it together, just so you don't think that I'm not fulfilling my promises. So we're going to go with module and then I guess modules.js. I'll grab that I currently have in the app.js, pretty much everything, and we copy and paste. And in this case, I also uncommented the say hi. Again, this all stays for your reference and you'll have access to it if you navigate to the GitHub repo. So grab everything in the app.js. I'll actually cut it out since we'll start from scratch and copy and paste. And now, of course, all this code is sitting in the modules. And just keep in mind that, of course, we're still referencing the names, utils, alternative flavor, as well as my favorite, the mine grenade. And back in app.js, now let's start by taking a look at the OS module. And OS module, the built-in module, provides many useful properties and methods for interacting with operating system as well as the server. And the general setup for the built-in modules, or even the external ones that we're going to cover a bit later, is going to be similar, where we're going to go with some kind of variable. And in this case, I'm going to call this OS for operating system. Then we're going to go with require. And then in the require, we'll have to pass in the name. So since this is a built-in module, of course, we don't need to install anything. Just remember that later when we work with external ones, yes, we'll have to install that module first. In this case, it is a built-in, so we just go with OS. But again, let me stress something. We're not doing dot and then /. No, we just go with OS. So that way Node knows, all right, so you're looking for the built-in module. And once we set this up, then we have multiple options. Either you can access those methods by just running this variable. So it would look something like this, where I go with OS, and notice the moment I press dot, I have all these options. So these are the methods and properties that I can use. Or if we know that we want a specific one, you can simply destructure it here. And of course, throughout the course, I'll use multiple setups just so you understand that both of them effectively do the same thing. So here I have access to all the methods and properties that this module provides. And of course, now we can go crazy. For example, I could get a useful info about the current user, which of course is me. So I'll say info about current and then user. And you know what? As a side note, I'll save here and I'll close all the files. It's just a bit annoying that I have all those tabs open back in the app.js. Once I have a comment, of course, now I would want to assign it to a user. And we'll simply go with OS, since that is the name of my variable. And then the method that I'm looking for is user info. I don't need to pass anything. I simply invoke it. And of course, since I would want to see the result, I simply go with console log, and then I'm looking for the user. And you can probably already guess that we'll just run node app.js. And there it is. Now, of course, I have a info about the user, which is me. So this would be a home directory. This is going to be the default shell and all kinds of useful stuff. Then I want to show you how we can get the uptime of the system. So effectively, how long the computer has been running in seconds. And I'll just add a comment. Method returns the system uptime in seconds. And the way I'm going to run that, I'll right away set up the console log. Just so you understand that, of course, we have multiple options how we can invoke those methods. You don't always have to assign to some kind of variable. Now I'll leave this one in here. So I'll leave the console log and then user. And let's say right above, or you know what, let's do it this way. So I'll leave the console log where the user is, and then let's go with another one. We'll go with console log. In this case, I'm going to go with template string, and we'll say the system uptime is, and then let's use a interpolation, of course. And the method that I'm looking for is uptime. So again, I go with my variable name, and I know I've said this before, but I just want to stress this point, just so we all are on the same page. And in this case, I'm going to go with OS, and then the method name is uptime. And then let's just add seconds. And again, same deal. Back in the integrated terminal, run node and then app.js. And there it is. Now, of course, not only I have the info, I also have the system uptime. And what's interesting, this actually is 100 seconds, meaning if I'll run this, notice that you would expect that this would probably stop at 60, right? Since we have 60 seconds in a minute. But no, actually, this one goes to 100. And then I'm just going to set up a object where I'll show you a few more methods. And then we'll move on to a next module, because again, the point is not to cover each and every method. The point is just to give you a general idea how the modules, the built-in modules would work in Node. So I'll clear my terminal, and then I'll create a object. I'll call this current, and then OS. And then in this object, I'll set up properties, and I'll set them equal to the method that actually returns that value from my OS module. So I'll go with name and OS, and this is going to be equal to a type method. Then I can get the release, and this one will be equal to OS, and then release. Again, we invoke it. Then we'll look for total memory and free memory, total and mem. And of course, I'll go with OS and then total mem. As you can see, somewhat predictable. And then we're going to go with free memory. And it's not going to be surprised if we're just going to go with free memory here. Let's save that one. And lastly, let's just console log it. And we should get a bunch of info about our current operating system. Again, we're going to go with node and then app.js. And not only I have the user information, not only I know how long the system has been up in seconds, I can also get some useful data about my operating system. And again, we're just scratching the surface. Of course, there's more methods and properties, but hopefully you have a clear understanding how powerful these built-in modules are in Node.js. Since in Node, we can interact with the file system, something we couldn't do when we used our JavaScript in a browser. Another useful module is a path module, which allows us to interact with file paths easily. And I'm going to remove all my code in the app.js because behind the scenes, I created a file by the name of 8 OS and module, and of course, copy and pasted the contents from the previous video. That's why in app.js, I'll remove everything And the setup is going to be exactly the same. We come up with some kind of name. Now, most likely it's going to be path. And then we pass in the module we would want to get. And in this case, of course, it is a path module. And then let's just start with a very useful property, a separator property that returns a platform specific separator. So if I go straight up with console log and then path sep, this is going to return my platform specific separator. So if I write node app.js, there it is. And of course, I have /. Now, if you're using a different platform, for you, the value might be different. After that, let's take a look at the path.join. So the join method, which joins a sequence of path segments using that platform specific separator as delimiter. And second thing it does, it returns a normalized resulting path. And in order to show you an example, I'll create a new folder. So not a new file, but a new folder. I'll zoom in and I'll say content. And inside of this content folder, I'll create another one. And I'll simply call this generic subfolder. And in this subfolder, I'll say a test and text file. And inside of the text file, I mean, you can place something, you can omit it, doesn't really matter. I'll just say text and then txt. And once we save it back in the app.js, now I would want to use that path.join method. So I'll say const and then file path is equal to path.join. And then we need to pass in those values as strings. So for example, since I'm looking for the content folder, I'll simply say / and then content. Then I know that inside of the content folder, I have the subfolder. That's another folder. And then eventually there's going to be a test.txt. So we go with test and then .txt. We save the sucker. And then if we'll console log the file path, we should see the whole path. And there it is. Now, of course, it is normalized and we get it as a value. So we have content, subfolder, test, and txt. So if I start adding some type of /, meaning trailing slashes, then of course they will be removed. We still get the normalized path. And we can also get the base name. So for example, I create this file path, but I only would want the last portion of it. How can I access it? Well, the method name is base name. So we're going to go with const and base and path.basename, and we just pass in that file path. And now if we console log the base, we should see the text. Again, these are just some of it. If you want just a directory, of course, you can imagine that there is a method that returns that as well. But since I don't want to cover each and every method, that's why I will skip that one. And there it is. Now, of course, not only I see my normalized path, but I also see the test.txt, which is my base. And the last method that I would want to showcase is path.resolve. And why it's so cool? Because it returns an absolute path. And once in a while in our applications, we need to provide that absolute path. That's why, of course, we'll have to use that method. And when it comes to path.resolve, it accepts a sequence of paths or path segments and resolves it into an absolute path. So below the base, I'm going to go with const and then absolute. And that one is equal to path. And we're looking for .resolve. And here, remember, when we talked about the globals, one of the first globals I covered was __ their name. So this is going to point to this directory where the app.js is located. And once we're here, then of course we just need to provide the rest of the values. In my case, that is content. Then I'm looking for sub folder. And then eventually I would want to get to the test.txt. I would want to get this absolute path. And then once I set up the value, of course, if I go with my console log and if I provide absolute, once I run node and app.js, you can probably guess that in the console, I'll have my absolute path to the test.txt. And if you're wondering why we would ever want that, well, remember, our application is going to run in different environments, right? So, of course, the path to some kind of resource is going to be different in my computer, in my local machine, than, for example, in Heroku. Hopefully, it is clear. And now, of course, we can take a look at the next useful built-in module. Nice. Now we know how we can work with path module. And like I mentioned in the previous video, we also have an option of interacting with a file system. So what I would want right now is to first create a new file. I'll call this 9 and we'll say path and module. Like so, JS. I'll grab everything that I have in the app.js, copy and paste. And once we have this one out of the way, I'll just remove and keep the app.js clean for now, as well as clear the console. And yes, we have an option of interacting with the file system and the module. The name of the module is FS. Now, essentially, there are two flavors when it comes to file module. We can do it asynchronously, non-blocking, or we can do it synchronously, which is going to be blocking. But for the time being, we'll just cover both of the setups. And then later in the course, we'll cover what are the differences and why you should prefer one over the other one. For now, just think of them as different methods. But eventually, yes, we'll talk about it, the whole structure of the node, and why would you want to use the non-blocking code instead, as well as different approaches when it comes to callback functions, different solutions. And for now, I would just want to show you both methods, essentially 4 methods, and then we'll just move on to the next topic. And in order to set this up, in this case, I'm just going to destructure right away the methods that I'm looking for. And in the first video, we'll take a look at the synchronous ones. So that's why I'll destructure read file and sync, and that is coming from require. And then the module name is FS. Again, please keep in mind, it would be the same thing if I were to go like this, FS, and then FS and whatever the name. I was going with read file sync, and of course I have access to it. I'm just showing you a different way how we can access those methods. We just destructure them out of the FS module. And then the second one will be write file sync. And then once I have destructured both of them, then I'm going to set up 2 variables. So first, we'll read 2 files. We haven't created those files yet, but in a second we will. And then eventually we'll create a new file with write file sync. So I would want you to go to the content folder. If you haven't created, then I suggest creating one. And I mean, I'll keep the subfolder just because I believe the path module is still using it. But in the content, I'll create a new file. So not in the subfolder, but actually in the content. I'll say first, and then txt. So this, by the way, sets it up in the content. So let me move it up. Or I'm sorry, this sets it up in a subfolder, I believe. And it tells me, do I want to move? Yes, I would like to move. And now I have the content that has the first txt. And then I have the subfolder with test.txt. Of course, if you want, you can place it in a subfolder. That's really up to you. But in my case, I would want them simply in a content. So I'll go with the second one, txt. And as far as the values, I'll say hello. This is first text file. And then, of course, we can copy and paste the value and just change it around to the second file. So in the second txt, we'll say second text file. And once we have both of the text files, now let's take a look at how we can read from the file system. And since we have read file sync, we know it is a method. And in that method, we need to provide 2 parameters. We need to provide a path to that specific file, as well as, well, what is the encoding. So the node knows how to decode a file. And generally, you'll go with UTF-8. And we'll first go with first. That's my variable. We'll go with read file sync, my method name. And like I said, we provide a path. We go to the content. And then inside of the content, there's going to be a first txt. And then as far as the encoding, The default one will be UTF-8, but if you want to be a bit specific, just set up the second parameter and notice these are all your options and just go with UTF-8. Okay. And then once we have everything in place, of course, we can copy and paste. This is going to be the value for the second one. And we just need to change the file name, of course. So we have the second one. And now in a console log, we should see both of the texts. So if I go with console log first and then second, I should have one long text. And let's go with node and app.js. And there it is. I have hello, this is a first text file. And I also have hello, this is the second text file. And once I have both of them, why don't we create a new file? And the method for that is write file sync. And the way it works, again, we provide two values, two arguments. One is going to be the file name. And if the file is not there, then of course, Node will create that file. And you'll see that in a second. And the second one is the value that we would want to pass. And I'm going to go with write file sync, write file sync. And like I said, first is going to be a path. So you can call this third, you can call this result, whatever you would want. In my case, I'm going to go with /content. And then we're looking for result and then sync. And this is going to be txt. And then as far as the value, if you want, you can simply pass hello world and test it. In my case, I'm going to make it a bit more interesting where we'll set up a template string. We'll say here is the result. And why don't we use the interpolation where we'll say first and second. So we'll have first value and then the second value. And you know what? Why don't we add here colon as well? So let's say first, and then let's place a comma, and then we're going to go with second. Again, if the file is not there, then of course Node will create one. And if the file is already there, Node by default will overwrite all the values that are in the file. And I'll show you that in a second. So I'm going to go here with node and app.js and check it out. Now I have result sync txt. And then inside there, I have here's the result. Hello, this is first text file. And then also have hello, this is second text file. And just to showcase that if there are some values, they will be overwritten by Node. Well, if I go with simple hello world and then I run node app.js, again, I have my new result. Now, if you just want to append to the file, well, we need to pass in one more argument. Notice I have the first one. I have the value that I would like to set up in the file. And the third one is an object, basically an options object. And here the property name is flag. And if you'll set this flag equal to A, then Node will append this. And the easiest way for me to show you that is run node app.js. And now we should have two results. So we have here is the result. And notice how we're starting a new line. Why? Well, because by default, we are overriding everything. And then when we add that flag, then of course we create a new value. So these are two very useful methods that we can use with Node to read files as well as create ones from the scratch. Beautiful. And once we have looked at the synchronous approach, like promised, I also would want to show you the asynchronous. And as always, let's start by creating a new file. Again, in my case, that is going to be 10 hyphen, and then I'm going to go with fa sync and JS. And of course, I'll grab everything in the app.js and then just copy and paste. And then back in the app.js, I would want to change these names. So I'm not looking anymore for the read file sync. I'm actually looking for a method by the name of read file. So this is going to be the asynchronous one. And the same goes with write file. Now, of course, we can remove all of this code as well. And the way the synchronous method works, we need to provide a callback. And if you're familiar with callback, essentially what it means is that we run that callback when we're done. So when whatever functionality we're doing is complete, then we run that callback, just like we normally would do with add event listener on a button. Remember, we go with add event listener, we add whatever the event, of course, with the button, that would be a click event. and then pass in the callback function. And that callback function will run every time we click on a button. So this is the same thing where we have the read file function, and we can simply use it since, of course, we have the structured. Then we need to provide a path. So again, we go with / content, and then the file name is first txt. And this is where we provide that second argument, and that is going to be a callback function. Now, in that callback function, we pass in two more arguments. First one is going to be error, if there is one, as well as the result. And then inside of the body, first I would want to check if there is an error, and then I can just return null, as well as maybe console log. So we go with if error, and then we'll say return null, or simply return whatever you'd want. And if you want, you of course can console log the error as well, like so. And then if everything is correct, well, then of course I'll have access to my data, which of course has the name, the parameter name of result. And since I would simply want to console log the result, I'm going to go with console log and the result. But of course, keep in mind that this is where you would set up the functionality. So let's go back, and we're going to go with node app.js. And in this case, something really interesting where we don't get the text, right? So we're getting this buffer. So this is what's going to happen where if we don't provide that UTF coding, then of course we'll get the buffer. Now, where do we add this encoding value? Well, right here in between the content as well as the path. So let's just go with string, and we're looking for the UTF. So let's say UTF-8, and we'll save that one, and let's run it one more time. And now, of course, I have node app.js, and then hello, this is the first text file. And now the $1 million question. Well, how we can set up the same functionality? Check it out. We have a read file, and then we simply create a new file with both of these values. So if you're familiar with callbacks, you know that, of course, we would need to set up that functionality inside of this callback where I'm getting this result. Otherwise, there's going to be an error, because the only way for me to access this result, if I'm setting this as a callback, is, of course, inside of this function. And this is what I was saying before, where, yes, eventually I'll show you a different approach, because inevitably we'll set up a callback help, and you'll see that in a second. So what I would want to do right now when I get back my first text file, well, now, of course, I would want to assign it to some kind of variable, and then I would want to read that second file, right? And then eventually, once I read the second file, then, of course, I would want to create that new file. And the way it's going to look like, I'm going to go with const, and I'll say first, and you can name it first text. I'm just going to go with first, and this will be equal to my result. Okay, awesome. And then right after that result, again, I'm going to go with read file, and then the same thing. We provide a path, so we go with content, and then in this case, of course, we're looking for second and then txt. Then we need to provide the encoding, so Node knows how to decode that, and we go with UTF-8, and then, of course, we need to provide our callback. Again, same deal, we go with error and result, and in order to speed this up, I will copy and paste. So just grab everything starting with if and ending with result, copy and paste. Again, this is the case where we're checking for the error first. If there is an error, we console log it. And if everything is successful, we assign this one to the second one. And then eventually now I want to set up my write file. So again, it is a function. We need to provide that value. And we already have result sync txt. That's why I'll create a new one, and I'll call this result and async. So again, we're looking for the content. Then we go with the file name, which is going to be result and async and txt. Of course, since there is no file, Node will create that for us. I'll right away set up my data. Now, if you want, of course, you can copy and paste this functionality. This is totally up to you, where basically we use two of them. And in my case, this is exactly what I'm going to do in order to speed this up. If you want to create something from the scratch, of course, that is also an option. and I'm just going to copy and paste. That's my template string. And again, if you want to add this flag, you can definitely do so. In my case, I'm just going to omit that. So here's the result. I have first and second. And the reason why I have access to them, because of course, I'm looking in the outside scope of this callback function. And then again, we have a callback function in the right file. I know there's tons of callback functions. That's why we'll have to set up a better setup when we're handling these callbacks, but we'll do that a little bit later. So for now, let's just add a comment here where we have first parameter, second parameter, and then the third parameter. And of course, this is going to be again our callback where we have error and result. And then inside of this callback, finally, we can take a look at the value. And of course, the value will be in this result. Now, of course, we're creating the file and all that, but hopefully you get the gist that if you would be doing something where you're looking for this result, of course, it would be over here. So again, let's check for error quickly. If there is an error, then of course, I would want to return as well as console log the error just in case. And if everything is correct, let me just console log the result. So I'll save it here. And two things we need to watch out for. Maybe there's an error. And second one, we should create a new file by the name of result and then async.txt. Let me clear the console and we're going to run node app.js. And I do get an error. And error simply tells me that I did not add the dot in front of the content. So I would need to go back to write file and just add dot. And once we add the dot, we are going to be in good place where I'll clear the console and I'll run one more time node app.js. And then the result will be undefined. Okay, that's fine. Like I said, in this case, we're not expecting anything back. But what's really cool that in the result async, we should have our text. Here is the result. Hello, this is first text and then the second text. So hopefully it is clear. This is how we would use the async pattern. So let me zoom out right now here and you'll see this famous callback hell. And in the next video, I would want to give you a brief description of what are the differences between the asynchronous approach or non-blocking approach and the blocking one, the synchronous one, as well as what are the alternatives to this callback hell. All right, and just to give you an early taste of the differences between the asynchronous or non-blocking and synchronous, which is a blocking code, why don't we set up a few console logs? Now, before we do that, I will create a new file and I'll say 11 here. And by the way, I definitely need to zoom in just so you don't think that I'm cheating. FS and async.js. And let's go to the app.js. We'll select everything and copy and paste. And of course, in the next video, we'll set up a different module in this app.js. So for the time being, I can just remove it. And then, like I promised, we'll set up some console logs. So why don't we go back to FS? And by the way, during this video, I'll zoom out because I definitely want to go back to this evil callback hell that we're getting from nesting callback within the callback. And as far as fasync, let me zoom in. And why don't we set up a console log in a few places? Let's say before we're accessing the file. So I'm going to go with log and we'll say start. Then we're going to go with write file sync. And then right after that, we're going to say I'm done with the task. And then inside there, let's write done with this task, copy and paste. And we're going to go with starting the next one. Starting the next one, meaning the next task. So that should do it. And now, of course, I need to go with clear. So clear my console. And I'm going to go to node. And then the file name is 10 hyphen and then fs. And we're looking for sync. I run it and notice something interesting where I have the start. So that is going to be before I read the files. And only then, once I'm done writing that file, I have done with this task. and starting a next one. And what we need to imagine that, of course, this task of getting those files as well as the second one of setting up that file, well, it might be very time consuming, right? And imagine that if we have even 10 users and they're all the time using our application, and if, for example, this one user does this one task or both of them, and they take really long time, what it means that Node is not going to be able to serve other users. And trust me, it is at the end of the day really, really big deal. And notice how JavaScript is reading this code synchronously. It just goes line by line. So we start with this task, then we read these files, and then we write the result. And again, if this is something that takes really long time, then pretty much your application is down. So no other user can do anything with that application because one of the users is, for example, reading these two files and then writing one. Again, this is a very simple example, but you need to picture that, of course, there's going to be tasks that take longer time. And as an alternative, let's take a look at the async approach. So here again, we'll set up some simple console logs. And again, we'll cover this in a bigger detail a bit later. For time being, let's just set up console logs and you'll see the biggest difference. Where I'm going to go with log and let's say start. So I'm going to do that before I read this file. And then I would want to go inside of the write file, the last one. And instead of console logging result, which of course is undefined, since in this case, we are not getting anything back. Now I want to go with done with this task. And then right after my first read file, I'm going to go with log and starting next task. Hopefully you're able to follow along again before the read file, inside of the write file, and then right after the first read file, because of course the other ones are nested inside of this callback. And then if we go to Node and if we just change it around to 11 and then FA, and I believe it was async, and if we run it, notice something cool where I have my start and then I right away have this starting next task. And eventually I have this done with this task. So what this means is that since we have this asynchronous approach, the moment we start this task, we just offload. We just offload this task and we continue with our code. So that way, when user number one, for example, comes here and wants to get this functionality, yeah, sure. Here, Node, just offload this task and then your application can keep on serving other users. Again, it seems a bit trivial at the moment because we have a basic approach, but hopefully you get an idea. Where in one case, we have everything happening line by line. So only when we're done with the task, we're starting a next one. And with this approach, we start a task and we just offload that task and then we start a next task right away. And eventually, yes, we have done with this task in a console as well. Now, as far as the implementation, as far as the callbacks, yes, this is a bit messy, right? Notice how we only want to accomplish few tasks and it's already somewhat of a pain. Now, alternatives are using promises as well as async await. Now, again, hopefully you understand that when we talk about reading the file as well as the writing of the file, I use this as an example of some kind of task that would take a long time. Now, for the remainder of the course, mostly it's going to be reading from the database, writing to the database, and that sort of thing. But this is a very good illustration of how some task would take some time. So, of course, we would need to use a callback. And as far as the callbacks, yes, you can use them, but the code is going to get messy somewhat quickly. That's why a bit later in the course, we'll take a look at the alternatives, which are promises and async await. And I have to tell you honestly, for the remainder of the course, we'll use async await because, in my opinion, it is just easier to work with. Excellent. And up next, we have HTTP module. But before we continue, let me just mention that I purposely won't spend too much time on explaining every single HTTP method we're going to use in great detail, and here's why. You see, starting from next section, all of our work, meaning code, in some shape or form, will revolve around server setup, aka HTTP module. So at that point, of course, I will cover every last bit of syntax in great detail. At this point, though, I think it's just a waste of our time. So if you're confused about something HTTP related, don't sweat it. We will return to that subject shortly and cover it in far greater detail. Now, if you're wondering why we bother with HTTP module at this point at all, since we're going to use it later anyway, you see, with the help of HTTP module, I believe I can show you some core features of Node in action and give you somewhat of a visual representation of them. Otherwise, I would have to base everything on slides, and I don't think it's the best approach. So, long story short, if you're iffy about something HTTP related, just please be patient, and I'll answer all your questions in the next course section. Nice. I think we've got a good initial understanding of how the file system module works in Node, and hopefully I did not lose too many of you. So hopefully there are still some students left in the course, because I fully understand that seeing this for the first time is probably a bit overwhelming. And what I would want to do next is cover the last initial module, the built-in module, and that is going to be the HTTP module, which is going to allow us to set up a web server. Now, please keep in mind one thing. We'll just cover the basics because the large part of this course is going to be creating your own server and setting up the API. Now, granted, we will use an abstraction on top of the HTTP module, and that is going to be the package by the name of Express. But the whole point is going to be exactly the same. That's why, again, we're not going to cover everything in greatest detail at the moment, because I don't see the point of repeating myself. And now I want to go back to app.js. I'll zoom back in just so you can see better what is happening. By the way, let me check my zoom level. So I'm going with settings, and I think that should do it. My zoom level is 2 at the moment. And then back in the app.js, let's grab the HTTP module and we'll assign it to some kind of variable as always. Let's go with a require, and we're looking for HTTP. That's the module name. And the method we would want to use is create server. Again, we'll assign this to some kind of variable. And in this case, the variable name will be server. Then we go with HTTP, create server. And this create server method is looking for the callback. And in that callback function, we have 2 parameters. And both of those parameters are objects. And since they're parameters, you can call it whatever you would want. But a common practice is calling them rec and res. Now, this first parameter represents the incoming request. So imagine a client is requesting from the web browser your web page. So you'll have information about the method and all kinds of useful stuff in that request object. And the response is what we're sending back. Now, we're not done. Of course, we'll set up more code here. But before we do anything, we also would need to specifically say what port our server is going to be listening to. And that's why we'll go with server and listen. So that's another method. And again, this is arbitrary, but I'm going to go with 5,000. Again, if this looks like a lot of gibberish where we have the request, response, as well as the ports, don't worry. Later in the course, I'll cover that in more detail, as well as show you some useful slides and all that good stuff. And as far as the response, well, we have few methods. We have write, so we go with a res, and again, this is the object. And notice here how I'm not using the rec yet, so I'm not checking for anything. I'm just concerned about my response, and the method name is write. And inside the write, we just come up with some kind of text, and I'll say welcome to our homepage. And once we have sent back the response, I also would want to end my request. So I'm going to go with res.end. And once we're done setting up the code inside of the callback function, now, of course, I would want to open up my terminal, clear everything, and we would need to spin the sucker up. And of course, the way we do that is node and then app.js. Since that is the file name, make sure that you save it though. So before I run, I'll save it. And then notice something interesting. Notice how we're not exiting. So previously, every time we ran the file, every time we ran node and then whatever the file name, we exited from the file, right? So node was done executing the code and we just moved on. Now, in this case, since we have a web server, well, what do web servers do? They keep on listening for requests. And actually, you want your server to always be up. And of course, if I go to my web browser and then I'll make this bigger. And if we go with localhost, and of course, in this case, we have 5,000. There it is. We have welcome to our homepage. So now, of course, we have effectively created our first website. Now, granted, it's very basic, but at least we have something on screen. And before we discuss the external modules and actually set up a module that nicely watches our code and does the restarts for us, I also would want to showcase what we have in the request object. Now, this is going to be a giant object, so I'm not going to cover each and every property. However, I would want to showcase a property that gets us the URL. And what would be the URL? Well, that would be an address. And if you worked with React or DOM, you know that, for example, for the homepage, we used /. And then if the client wants to go to, for example, about page, he or she would enter / and then the about. Now, in our case, notice how we're still serving the same content. So just to give you a quick introduction of the request object, as well as set up a bit more realistic application, we're going to go with the request. Now, again, if you want, you can log it. So we're going to go here with request, and you'll see that it is a giant object. Now, since we made some changes, we do need to stop it, and then we'll go with node app.js. But notice how we're not right away console logging the request object. Why? Well, because server is waiting for those requests. So we need to go back to our browser and then refresh. And then, of course, once we navigate back, like I said, this is going to be a giant object with bunch of useful info. Now, what we're looking for is the URL property, because that URL property is going to tell us, well, what address client is requesting. So what endpoint the client is requesting. And like I said, for the homepage, the common practice is using simple /. So in here, we can set up the if statement where I say if request URL is equal to the homepage, then of course, this is what I would like to send back. And just to speed this up, I can tell you that we can cheat a little bit where we can just place everything in the end. And in my case, I'll just cut out my string. So we have res.end. So now we simply send the text. And now, of course, I also would want to check for the about or contact or whatever. So in here, let's go with if and then request and URL. And if that one is equal to about, then of course I can send different text. And as far as the text, I'm just going to say here is our short history. And then lastly, well, what happens if the user is trying to access a resource that doesn't exist on our server? So we'll have the about page, we'll have the home page. What about if the user is asking for a contact page that we don't have? Well, here we'll simply set up a default response. We'll say res.end, and just to make it interesting, I'll set up the template string, and I'll show you that if we really want to, we can also pass in directly HTML, and I'll say, oops, an exclamation point. I'll close my HTML. Again, please understand, this is just a basic scenario. Of course, that's not how we'll be setting up our APIs or nothing like that. But just to give you a quick intro, we'll do it quick and dirty, where there's going to be a paragraph, and we'll say we can't seem to find the page that you're looking for. Page you are looking for. And at the very end, I would want to set up a link that allows the user to navigate back. So I'll go with href and I'll say /, which just means homepage. And we're going to go back home. Let's close our link. Let's save that one. So at the moment, of course, we have the about. And by the way, almost forgot. Yes, we do need to stop the server. And we need to go with node and then app.js. Refresh one more time. There it is. Notice how we don't have the about. We can't seem to have the page you're looking for. And that is actually a bit interesting because it should be available, right? And of course, the reason is because I messed up on the URL property. My bad. Let me do this one more time. And we'll stop the server here. Again, let's run node app.js. And now we should have, here's our short history. That's our about page. Then we have the home page. And of course, you are already familiar with our error page. So if I'll go with error or any kind of resource that doesn't exist, then of course we'll get the error page. And of course, we can bravely navigate back home and we go back to our homepage. That should do it for the quick intro of base modules. And now, of course, we are ready to move on to our next topic. All right. At this point, we're familiar with two types of modules, our own, as well as the nodes built-in ones. But just like in any good infomercial, I'll say, but wait, there's more. We also have access to the world's biggest code store. And before you seriously start questioning my mental state, imagine this scenario. You're building an app. And of course, as any good app, it needs to have a slider, just for funsies. Now, at this point, you generally have two options. Build it from the scratch yourself, or search on Google and copy paste someone else's solution. While I have no issues with either of these options, keep in mind that someone somewhere has struggled with the same issue, the need for the slider. And there's a good chance that that person was kind enough to build it and share the whole project with us. So our only job is to go through the docs and with the help of one command, just add it to our project. We can do that because when we install Node, we automatically also install NPM or Node Package Manager. And NPM enables us to do three things: reuse our own code in other projects, use code written by other developers, and lastly, share our own solutions with other developers as well. The NPM project is hosted at npmjs.com. Again, the site is npmjs.com. And here you can find everything starting with useful utility functions to full-blown frameworks and libraries. And as an example, if you're familiar with React, you know that React has the Create React app package. And of course, it is hosted on the NPM. A typical Node project will have more than few NPM packages installed as dependencies. And before we install some cool packages, let's talk about naming. NPM calls the reusable code a package. And a package essentially is a folder that contains a JavaScript code. Now, another names you'll hear are modules and dependencies. And to tell you honestly, at this point, all three are used interchangeably when talking about shareable JavaScript code. So don't be surprised if during the course I call them any of these names: package, dependency, or module. At the end of the day, they all mean the same thing. Lastly, let me just mention two things. First, there is no quality control in NPM registry. Anyone can publish anything. So it's up to you to sniff out the empty and useless packages. And yes, there are quite a few of those ones out there as well. A good indication of the security and usefulness of package is the amount of weekly download. If the number is high, meaning if it's popular, it's a good chance that it's a battle tested and ready to go. And that brings me to my second point. Remember the slider example we discussed in the beginning of the video? when it comes to NPM packages, there's a good chance that if there is a bug, someone else has already fixed it. And as a result, it's already fixed in the package, or there's a working solution. All right. So that should do it for intro. Let's start using Node Package Manager in our own project. And as a side note, if you want to search for some packages, just visit npmjs.com. And then, for example, if you're looking for the Bootstrap, you'll find the package. And of course, you can click on any of them. This will bring you to the docs, as well as weekly downloads and rest of the stuff. Once we're familiar with Node Package Manager, let's see how we can start using it in our own projects. And the good news is that it's much simpler than you would expect. You see, when we install Node, we also install npm. And because of that, we have access to npm global command. And you can check the npm version by running npm -- version in your terminal. Just keep in mind that the version most likely won't be the same as your Node's version, and that is totally okay. So you can either do that in the terminal or, of course, in the integrated terminal, and you can simply type npm and then -- version. I believe you can also check by --v, and there it is. Of course, now we have the version for our Node Package Manager. And then we have two flavors. We can install package as a local dependency, and that just means that we'll only use that package in this particular project that we're working on. And the command for that one would be npm install, or I for short, and then whatever is the package name. So whether that is Bootstrap, Lodash, Express, or whatever. Or we can install dependency as a global dependency. And that just means that we can use it in any project. And the command for that one would be, again, npm I or install, whichever method you prefer, and then -g. So this is going to be the flag, and then again the package name. Now, when you install something globally, most likely on a Mac, they will ask you for the sudo. So you'll have to provide the credentials. That's why you'll run sudo npm install and then -g, and again package name. As far as which one you'll use more often, that definitely will be a local dependency flavor. Because even though, yes, you can install packages globally with arrival of npx, there's actually less and less need for setting up something globally. That's why we'll focus on local dependencies first, how to set it up in our project. And then in a few videos, when we talk about npx, I'll cover why there's less need for setting up something globally. Now, there's one more thing that we would need to set up in our project as far as dependencies. So I know you're eager to start installing the packages, but let's just wait a little bit. And in the next video, we'll add that extra thing that we're missing right now. And then we'll be in good shape. And then we'll start installing every package under the sun. Excellent. We now know that we have access to the npm global command. We now know that in order to install the local package, we will need to run npm I and the package name. So what are we missing? Well, we're missing file by the name of package.json. And essentially, you can think of it as a manifest file that stores important information about our project. And there are three ways how you can create package.json. First is the manual approach, where you just create a package.json in the root. And please do that in the root if that's something that eventually you decide doing. And there, of course, you would need to create each property. Or there are two ways how we can automate this. And the first one is running npm init. And in there, they will just step by step ask you the questions. And if you want to skip it, you can just press enter. And the another way, the third way, is running npm init with a Y flag, and then everything is set up as default. So I'm not going to show you the manual approach. It's just too time consuming. And we'll right away go with npm init. First, I'll show you the step-by-step approach. And then, of course, I'll show you how everything is set up by default using the Y flag. So go to your terminal and just type npm init. And there it is. Of course, now they tell you that there's going to be a walkthrough of creating a package.json file. And the first one is the package name. And by default, of course, it is going to use the folder name. Now, keep in mind that if you eventually want to publish this package, then the name has to be unique. So you need to make sure that nowhere in the npm you can see the package with the same name. And I'm just going to go with tutorial. As far as version, we'll talk about versions shortly. So I'll just skip this one. As far as description, whatever, again, is just the default. Now, as far as the entry point, eventually we'll change it, but for now, it's good enough. We're going to go with one intro.js and then the test command, as well as git repository and keywords and author and license. And we simply say yes, and we are in good shape. So now, of course, we have the package JSON file with name, version, description, as well as the main property, and of course, the script's author and the license. Now I'll remove it. I'll say delete, and I'll show you that, of course, you can skip all of those questions by simply typing npm init and y. And as you can guess, yes, of course, you can come here later and then just change these values. That's why it's definitely faster to just type npm init and then the y flag. So why do we need this package JSON? Well, because if I would want to install the package, the local package, now, of course, this package is going to be stored as a dependency. And to show you that, let's just go with npm. And you know what? Let me clear the console first. So we're going to go with npm I, and then we're going to go with the package name Lodash. And if you're not familiar with Lodash, it's just a utility library, and I'm just specifically using for installation purposes. There's no real reason to have Lodash for our own project, but it's just something pretty interesting that I would want to showcase. That's why we're using Lodash. And we run it, and notice how we installed the package, and check it out. Now in the package JSON, we have dependencies property, and it's an object, and inside of that object, we have a package by the name of Lodash. Now, I'll show you in this video, or maybe in the next one, why it's so important to have this package JSON. But another thing that I would want to showcase, once we can see that we have dependencies property, if you go in your Visual Studio Code and if you click on Refresh Explorer, what you'll also notice is this node modules folder. And in that node modules folder, this is where all the dependencies are stored. So if you don't have that folder already, npm creates it. So in our case, of course, we didn't have any dependencies. So when we install that first dependency, npm creates that folder, and this is where you'll find the dependencies. Now, notice something interesting where for the Lodash, we only have one folder, right? So we have only one dependency. But when we need to keep in mind that, of course, there's going to be some packages that have other dependencies. And that's why I first installed Lodash, just to showcase that, yes, once you install dependency, of course, it is going to be in the node modules. But if you'll try to install a package that is bigger, that uses other dependencies, you'll notice something pretty cool. Where if I clear my terminal and if I'm going to run npm I and then bootstrap, again, you can use any other package you could want. This is just to showcase how the packages work. We won't use the bootstrap in this project. So once I install and once I refresh, check it out. Not only I have Lodash, not only I have bootstrap, which I installed, but since bootstrap is using jQuery as well as the popper.js, now these are installed as dependencies. And if you take a look at the dependencies property, now of course we have the bootstrap as well. And again, the whole point of this video is to showcase why we would need package JSON. So we need it because we need to provide information about our project. And inside there, a very important property is the dependencies one, because in there, we'll just store the dependencies which our project is using. And then some packages are actually going to use more dependencies and they will be automatically installed as well. In our case, that was Bootstrap. And just to give you a taste of the package, why don't we just navigate to app? And I'm going to do that below the comments. Of course, you probably would need to clean the file. And as a side note, the last module, the HTTP, I saved in a file by the name of 12 HTTP. And back in the app.js, in order to start using the module, in our case, I guess I'm going to go with Lodash. First, I would need to set up the variable. And common convention is calling the variable like so. And we'll set it equal to require. And now, of course, we have access to the Lodash. Now, this is the difference between node packages, like, for example, the HTTP or the file module or whatever, and the ones that you install, the external ones. The external ones, you always have to install first. If you won't install the dependency, well, Node won't be able to find it. So in our case, we did install the dependency, the Lodash. So now, of course, I can just assign it to the variable. And since Lodash is utility library, why don't we test out one of their methods? And I'm just going to go with items and I'll create an array of arrays. So items is going to be an array. However, the items are going to be arrays itself. So 2, then 3, and then we're going to go with 4. And Lodash has this method, the flat and deep method, that effectively will just spit this back as a flat array. And the way we set it up, we just go with const, and I'll call this new items. And then since we have access to everything in this variable, now I can simply go with underscore here, dot, and then flat and deep. So flat and deep, and then we'll pass in the items. And now if we console log new items, and if I go to my terminal and just type node app.js, and by the way, I need to save it. So let me go back. I'll say node app.js. And once we run, check it out. In a console, I can see, of course, the 1, 2, 3, 4. So Lodash has the method by the name of flat and deep. We have access to it because we install it as dependency. And now, of course, I can start using it. Now, we're not going to use Bootstrap in this project because that would be too time consuming. Bootstrap was just used so you can see that some dependencies will have more packages. So once we install one dependency, there's actually going to be more dependencies. And hopefully you have a clear understanding of how we would set up package.json, how we would install the package. And next video, I would want to showcase why having package.json is so crucial and so beneficial when we are starting to share our project with other developers. Awesome. We have package.json. We installed few dependencies. And now I would want to cover why having package.json is so crucial when we start sharing our project with other developers. And for this example, I'm going to use GitHub as well as few basic Git commands. And my assumption is that since this is somewhat of a advanced course, you're already familiar with Git and GitHub, and you have the account. If you don't, please stop the video, create the account, and just use your favorite search engine to learn about the basics of setting up the GitHub repository as well as basic Git commands. So our task is to push this up to the GitHub. And now, $1 million question. Are we just pushing everything up, including the mode modules, which for the most projects is going to be somewhat big? I believe I just checked. In our case, it was like 9 megabytes, but trust me, it always gets way bigger than that. Or we would just want to send the code. And you can probably already guess that since I'm implying that the size is too big, that we'll have to push this up to the GitHub without the node modules. And we'll start by creating a dummy repo on the GitHub. So let me open up a new window. I'm going to go with GitHub and I'll just create a temp repo. And then I'm just going to create a repo and I'm looking for these 3 commands. Essentially, I would want to get that URL, the remote URL, so I know where to push it. And then inside of the repo, before we set it up as GitHub repo, first I would want to go with new file and we'll create a git ignored. Because of course, what I would want is to place the node modules in a git ignore file, because that way they will be ignored by my source control and I won't be pushing up this giant folder to the GitHub, because you'll see in a second that there is no need for it. So we're gonna go with / and then node modules. And if you're not familiar with git ignored, it's just a file that specifies which files are going to be ignored by the source control. And in our case, as you can see, I'm placing node modules inside there. Then I'll clear my console and I'll just initialize this as an empty git repo. And then we'll add everything. So git add, git commit. We'll just say first commit. And then I'll copy and paste those 3 commands in order to set up that URL, the remote URL. And once I have this in place, should be able to go back to my GitHub. And there it is. This is my repo. Now, probably your next question is, okay, so we pushed it up to the GitHub, but I can clearly see that in my app.js, well, technically, I'm using the nodejs dependency, right? But we didn't push up the node modules folder. So how the person who is going to get this repo will be able to run the code in the app.js, since there's no node modules and you told us previously that we can only run it if the dependency is there. Well, let's check it out. I'm going to go with clone option. So I'll just get the URL. I'll navigate back here and I'll do that in desktop. Again, it doesn't really matter. We're just going to go with desktop and then git clone. Now I copy and paste the URL. I'll open up a new instance of my text editor, copy and paste. And this is where the magic happens. If we have package JSON, we simply need to run npm install. And what is going to happen, the npm will check for dependencies that we have in the package JSON and automatically set up that node modules folder. So if I go here, first of all, I can see that there has been some changes. That is already good news. That just means that I have my node modules, and if I refresh, check it out. So now, of course, I have my node modules folder. And if you have been using React applications, you're probably already familiar with this one, where again, when you are setting up the code, you're not sharing the node modules folder. And I can showcase that by taking a look at my React projects. And that's not what I wanted. I didn't want to look at my awesome picture. What I wanted is a React. And then let's go with projects. And you'll see that in that repo, we have bunch of folders, and each folder has 2 more folders, final and setup. And now check it out. None of them have the node modules, because imagine the size of this sucker if I would push for every project, for every folder, the node modules. Instead, I have package JSON. So when you get the repo, when you clone the repo or download or whatever, then of course you get the package JSON. And in here, these are the dependencies. And you just run npm install and they are being installed. Okay. Hopefully it is clear that's why it is so crucial to have the package JSON, because we can just share the code without dragging the massive node modules folder with us. We can simply just provide what packages our project is using. And then once we get the repo, then we just run npm install. That is the command. And then npm will install all the packages that are in the dependencies. Awesome. We're familiar with npm. We're familiar with package JSON. Now let's finally install the dependency that we'll use for the remainder of the course. And that is no other than the nodemon. And of course, if you want to get more info, you can visit the npm and you can search for the package. But as far as the general setup, it's just going to watch our files and then restart our app for us. So that way we don't have to each and every time type node and then whatever the file name. And we can install it as a simple dependency. That is definitely an option. But since I also would want to cover dev dependencies, we'll install that as a dev dependency. And the command for dev dependencies is following, where we go with npm and then I or install whatever. And then we go with node mon. So that is the package name. And then you can either do -d. So that just signals that that is a dev dependency, or you'll see this save and dev. So again, whichever method you choose, that is really up to you. But just remember that both of them will save it as a dev dependency. So let's install it, and then I'll talk about it. Well, why we would want to set up as a dev dependency. And the reason for that is because if we think about it, do we really need nodemon in production? And the answer is no. When we push it up to DigitalOcean or Heroku or whatever, we'll of course use something more serious than nodemon to restart our application. PM2 comes to mind. But while we're developing, yeah, that is an option. So in this case, we'll add right away nodemon to the dev dependencies. Now, what else? What kind of packages we would add to dev dependencies? For example, testing packages. For example, linting. For example, formatting, and that sort of thing. Again, nothing stops you from jamming this in dependencies, but if you think about it, it makes way more sense if we add this as dev dependency. So we use it while we are creating the app. But then once it's in production, then we just share the dependencies that actually the app is using, not the ones that we used while we developed the app. Hopefully that is clear. And once we have the package, we're almost there. Now we just need to understand how the scripts work in a package.json. And at the moment, as you can see, we have the test one. We won't use that one. And inside of the scripts object, we just set up the commands. And as a side note, we can set up the command right now, even without the nodemon. For example, I could go with start, and that command will be equal to npm, node, and then, for example, app.js. So that is my command. And once I save my package.json, instead of running this node app.js, I can simply run npm and start. And there it is. As you can see, same functionality. I run app.js and I get back the array as well as the hello world. Again, we still exit the application. So it's not like we're out of the woods, but I'm just showcasing that, yes, we can set up the commands, and then in the command, we just provide a value. And in this case, of course, it is node and app.js. Now, for some commands, you can simply type npm start, as you can see, but for some of them, you'll have to provide the full value, and that is going to be npm run. And in order to showcase that, I'm going to go with dev, and that one will be equal. And in here, we're going to go with a node mon and then app.js. So instead of running node, like we're doing in the start, now I'm setting up a dev command. And in order to run this one, I'll have to go with npm run and then whatever is the command name. Again, some of them you'll be able to use the shortcut where you go with start, and some of them you'll have to go the full route with npm run and then whatever is the command. And as a side note, yes, you can still run npm run start. This is also going to invoke the command, but in our case, we have the dev, and in here I have nodemon and then app.js. So let's try it out. Let's save first the package.json, and you should notice something pretty cool, where if I go with npm run and dev, now I'm spinning up the nodemon, and it tells me that nodemon is watching my application. And since I know that, of course, we can test it out, where I'm going to go with console log, and then instead of the hello world, which I have after new items, I'm going to go with hello people. And you should see something interesting, where once I change the text, yep, nodemon restarts my app. And now, of course, my value is hello people. Awesome. So now I don't have to type every time the node and then whatever file name. Nodemon automatically just restarts my app, and I simply set it up as a script. Now, if you want to change this around, if you don't want to run npm run dev, you can simply say nodemon and then app.js and just remove the dev one completely. And as a side note, again, if you have worked with React projects, you are familiar with this setup because for React, again, we run npm start, and then there's a value that spins up the whole React dev server where we can see our application. Not bad, not bad. Well, we're still on a roll. Let's cover how we can uninstall the package as well. And as a side note, if you want to stop the nodemon, just press again Control and C. And notice how we're, of course, stopping the nodemon. And again, if we would want to spin it up, we'll just go with npm start. And as far as uninstalling the package, we have the command for that. And the name is uninstall. So I'll stop the nodemon. And in the terminal, I'll type npm uninstall. And then, of course, the package name, which in my case is going to be a bootstrap. Now, this is one of the approaches how we can do that. And there's also a nuclear approach. Now, why I'm calling this a nuclear approach, because that way we remove the whole node modules folder. And don't worry, once you run the npm install, then of course you set everything back up from the scratch, as well as you would remove this package log.json. And don't worry, I will cover the package log.json file a bit later. And the way that is going to look like, well, we can first clear the terminal. I'll install the bootstrap from the scratch again. So I'll say bootstrap here. And by the way, probably need to add npm I. And now again, as you can see, I have it as my dependency. And then, like I said, the nuclear approach is removing the node modules. Yep. And then removing the package log. And then just running npm install. Now, of course, in the package JSON, if I want to remove the bootstrap, for example, in this case, I can simply remove it from my dependencies. So I just remove it in the package JSON, then clear everything. And then we go with npm and then install. And now we'll get from the scratch the node modules, since we're the ones who removed it. And also we'll get that package -lock.json. Now, why am I showing you that nuclear approach? Because if you have used Gatsby, you know that Gatsby is somewhat notorious for sometimes just being a little bit annoying, where you do need to remove the cache folder, you do need to remove the node modules as well as package lock. And then once you start up everything from the scratch, then as a magic, the Gatsby app starts working. And check it out. If we take a look at the node modules, now, yes, there's a bunch of modules that nodemon is using, right? But there's no bootstrap, and I can clearly see that because there's nothing under the letter of B. So we can clearly see that we removed bootstrap from our dependencies. All right, and now let's take a look at how we can install package globally and what would be some of the use cases. And first, let's start with command. Let's jog our memory. Command was npm install and then -g and the package name. And in Mac, they might ask you for permissions. So you'll have to start with sudo and then again, same spiel. npm install, blah, blah, blah. And first, I would want to showcase that I haven't installed nodemon globally. And the easiest way for me to showcase that is by running nodemon and app.js. So we'll try to install nodemon package globally. Why? Well, because then I can use nodemon in any of my projects. At the moment, I have it as a local package. And of course, I can spin it up by running npm start. But let's imagine a scenario where I have, I don't know, 20 node applications and I'm constantly working on node applications. So to make my life easier, I will install nodemon globally and then I won't get this error. Because at the moment you can see command not found, nodemon. All right, so how do we do that? Well, we can install it in our terminal or we can do it in the integrated terminal. It doesn't really matter. When it comes to global packages, you can install it from anywhere. So in my case, I'm just going to navigate back to my terminal just so you don't think that I'm cheating. And I'll zoom in and we'll simply run. And by the way, I need to start with sudo and then npm install and -G, and of course, we're looking for the nodemon. So now, of course, I'm prompted to enter my password. And once I enter my password, of course, I'm going to install nodemon globally. And now in any of my projects, I can simply go with command of nodemon and then whatever is the file name. Now, to show you some of the use cases, if you work with Gatsby, you know that they have the global Gatsby CLI tool. And that was one of the reasons why you installed something globally, is because, well, you used one of the frameworks, for example, React or Gatsby in this case. And then, of course, in order to set up the Gatsby project or React project, you needed to install this globally. Now, things have changed, though, with arrival of NPX. And I'll talk about the NPX at the end of the video. But notice, if you navigate to your React docs and if you look for create a React app, which again was something that you needed to install globally, now they suggest this NPX route, where essentially you go with NPX and then again, whatever is the command name, for example, for create React app, that would be create React app. For Strappy, the headless CMS, that would be create Strappy app. And hopefully you get the gist, where for every resource that of course would be different. And with that command, you don't have to install that tool globally. For example, again, in our case, we're installing nodemon, but normally prior to NPX, you would install this create React app globally, and then you can spin up those React projects. Now I'm going to go back to my terminal. As you can see, I was successful. So what's going to happen if I go back to my project and if I run nodemon and app.js, since I have installed that package globally, there it is. I spin up my app.js. And if you don't believe me, I can change it back to hello world and I have no issues. Hello world. And there it is. Now, of course, I have hello world in the console. So hopefully it is clear that yes, we can install packages globally. And yes, one of the biggest use cases was working with some type of front-end library. But with an arrival of NPX, things have shifted, where now those libraries suggest using the NPX route instead. As far as my personal preference, since I'm recording a lot of courses, and since some of the global packages usually introduce some kind of bugs to the students, now, not for all the students, but there's always this one student who just has a lot of issues with the global package. Personally, I avoid them as much as possible. So I always either use the NPX or I just set it up as a local dependency. Again, it's not a rule. You can do whatever you would want, but I'm just telling you what is my preferred option. As far as what is NPX, it stands for execute, and official name is the package runner. It is a feature that was introduced in NPM 5.2. And again, the main idea is following, where you can run that CLI tool, for example, in this case, create React app, without installing these globally. So as long as you have NPM with a version of 5.2 or greater, instead of doing this whole spiel of setting up the CLI tool globally, you just go with NPX and then whatever is the tool name. And of course, the last one is the folder name. As far as the package log JSON, why do we need it? Well, if we take a look at our dependencies, we can see that they have versions. And if you remember, some of the dependencies have dependencies on their own. And of course, we need to keep in mind that those dependencies have versions as well. And for example, the person who gets your project, you probably want them to have the same exact setup, because keep in mind, as these versions change, well, so does some of the functionality, correct? So for example, you set up to your whole project, you use some kind of dependency that uses some other package, and that version changes, not for example for the bootstrap, but for the jQuery. And then pretty much your project is obsolete, meaning it might get some bugs because the version of the jQuery changed. So that's why you have this package log JSON. And in there, you have those specific versions for all the packages, not only for dependencies, but also for the packages that the dependency is using. Now, as far as this version, we have three values, and you can think of it as a contract between us, the people who are using the package, and the person who is creating. And the first number is a major change. So when this changes, that means that there are some breaking changes. Now, the second one is a minor one. So that means that it is backward compatible. So, for example, if this changes to 18, I shouldn't expect any breaking changes. And the last one is just a patch for the bug fix. So that's also something to keep in mind when you decide to publish your own package. That, of course, that's why you have here this version. Now, lastly, I would just want to mention that if you're interested in more info about the package JSON, I would suggest this resource. So I simply went with package JSON, then keep on scrolling, and you're looking for, I guess, this blog post, right? So the name is The Basics of Package JSON. And in here, you'll literally find everything explained to the smallest detail, whether that is a name, version, and the rest of the fields that you can find in a package JSON. Beautiful. We now know how to utilize NPM, and for starters, as a result, for the remainder of the course, instead of frantically typing node app.js in a terminal, we'll simply spin up nodemon, and it will watch for the changes and restart the app for us. Now what? Before we move on to creating servers with Express.js, there are a few important node topics I would like to cover first. And those topics are following: event loop, async patterns in Node.js, events emitter, and streams in Node.js. While these topics are extremely important, please keep in mind that our goal is to only understand the general ideas behind these concepts. And I only introduce them so you have an overall understanding of how things work in Node.js before we build our first Node.js app. If you're not satisfied with my explanations or simply want to do more research by yourself, just type any of these terms in your favorite search engine, and I can guarantee you'll find plenty of useful resources within a matter of seconds, like blog posts, YouTube videos, and conference talks. With that said, it's my strong opinion that it might be easier to understand those concepts more deeply. So not just a general understanding, but understanding them more deeply once you have one or few working Node apps under your developer's belt. Let me also mention that in order not to waste your time with time-consuming setup, in few upcoming videos, I will run some pre-built code. Let me be very clear though. I'm only going to do that in a few videos, and for the remainder of the course, we will type out everything together. All right, and let's kick things off by discussing the event loop. Now, event loop in Node.js is one of those topics where I could spend the entire course discussing it, and it still wouldn't be enough. So let's try to avoid that and instead just understand the general concepts. While there are tons of useful event loop explanations out there, the one that I probably like the most is this one. The event loop is what allows Node.js to perform non-blocking I/O, so input and output operations, despite the fact that JavaScript is single-threaded, by offloading operations to the system kernel whenever possible. And as you can see, I'm reading straight from the Node docs. Now, don't beat yourself up if this sounds like a lot of gibberish. There's a reason why one can dedicate the entire course just for event loop. It is a pretty complex topic, but one word I do want you to remember is this offloading, and you'll see why in a second. Also, don't worry, I have prepared more examples as well as some slides to get my point across. But just in case you're not happy with my examples, or you just want to explore the Node event loop in greater detail, here are a few external resources I find particularly useful. When it comes to blog posts, just go to your favorite search engine and type Node.js event loop. And the one that I find really useful is this one. And the resource is node.js and not .org, but it is .dev. And then follow the link and here they cover event loop in great detail with a lot of cool examples and pictures and slides and all that good stuff. And when it comes to videos, I would suggest going to YouTube and then just type event loop. And the first video that's going to pop up is going to be the event loop bot in browser JavaScript. And I'll talk about it in a second. And the nodejs specific event loop video is this one. I believe it's 15-minute long, and you can see the name over here. So this is a very, very useful video where the speaker covers a lot of useful details about Node.js loop in great detail. And the reason why I'm suggesting the first one as well, what is the language that we use in Node? That, of course, is JavaScript, right? And even though there's some differences between the event loop, the one that we use in the browser, and the one that is in the Node.js, if you understand the concepts behind the event loop that we use in a browser, trust me, you're already halfway there to understanding how the Node.js event loop works. Since it's such an important topic, like promised, I have prepared some of my own resources as well. We'll start with the slides and move on to the code examples in the next video. As a side note, I made all the course slides available on courseapi.com. Again, that website name is course-api.com. And once you click on the slides link, you'll see all the slides. And I would want to start our discussion by taking a look at what it means that a JavaScript is synchronous and single-threaded. And effectively, it's just a fancy way of saying that JavaScript reads everything line by line. So for example, if I have console log with first task, then I have a for loop that takes some time, in this case 2 seconds, but that could be 10 seconds, that could be 20 or whatever. And then I have another console log of next task. JavaScript will just start reading everything, and it will read it line by line. And if this takes a long time, it will only run the next task once it's done performing this time-consuming one. So hopefully that is clear, that JavaScript just reads everything line by line. And now let's take a look at our second slide. And in here, we can see the solution if we would want to offload something to the browser. So when we're building browser JavaScript apps, we have this option of offloading to the browser. Now, of course, it doesn't mean that we can offload the for loop. That's not going to work. This effectively is still going to be the blocking code, but browser nicely provides the API where we can offload those tasks to the browser, and only when the task is done, then we execute the callback. And probably the example you have done the most is the fetch, essentially when we make the network request, but we can also do that, for example, with a set timeout. So I still have console log with first task, but then even though my set timeout function has the second argument of 0, so essentially I have set timeout function, I provide the callback function that's going to be executed in certain amount of time, even if this is 0, meaning you would expect this one to run right away, it only runs after the next task. So once JavaScript is done executing the immediate code, only then it executes the callback. So in this case, we have the set timeout, the API that is provided from the browser, and we just say that we would want to execute that in 0 seconds. So effectively, there is no wait time. However, JavaScript will first execute this code, and only then will execute the callback. So that way we can offload those time-consuming operations to the browser. Again, it doesn't mean that we can offload for loops. It means that browser does provide some APIs where we don't have to write the blocking code. Now, let me be very clear though. When I say we cannot offload for loops, what I mean is that we can still write blocking code in JavaScript. But the browser does provide some nice APIs where we can offload those time-consuming tasks. And that brings us to our main friend, the Node.js event loop. Again, before I go over the example, let me stress something. Event loop is somewhat complex, and this is just to give you a general understanding. So let's imagine this scenario. I have an app, and just like any cool app, I have subscribers or users or however you would want to call them. And in this case, since my app is so popular, I have 8 of them. And what do the users do? Well, they're probably being annoying and they're requesting something from the application. And as the requests are coming in, the event loop is responsible for avoiding this type of scenario. So let's imagine this. I have all these users, the requests are coming in, but Larry the Little decides that in his requests, there's going to be some kind of time consuming, I don't know, database crawl or something like that. So effectively, he's requesting something, and behind the scenes in my code, that means that I need to perform something that takes a long time. So in this case, the event loop just registers the callback. So it registers what needs to be done when the task is complete. Because if the event loop wouldn't do that, then we would have this scenario where the requests are coming in, and because Larry is requesting something that takes a long time, the rest of the users would have to wait. And essentially, it's not that the actual operation takes a long time. It's just the fact that we're wasting our time on waiting for that operation to be done, and only then we can serve the other users. But what the event loop does, it registers the callback, and only when the operation is complete, it executes it. Now, keep in mind that, again, we're not executing this right away when we can. Effectively, it's the same scenario where we run our immediate code first, and only then, when we have the time, we execute the callback. So, for example, in this scenario, if I would have 100 console logs after the next task, I would run them first, and only then the second task would appear here, regardless of what is the time set in here. Because again, we're running our immediate tasks first, and only then we run the callbacks. So the same thing happens here, where the requests are coming in. Let's say that the operation is complete. We first registered the callback, operation is complete, and instead of executing that callback right away, it effectively gets put at the end of the line. And then when there is no immediate code to run, then we execute the callback. Hopefully that is clear. Event loop is our best friend because with the help of event loop, we can offload some time consuming operations and effectively just keep all our users happy. All right. And once we have looked at the event loop in theory, to hammer this home, let's also take a look at some code examples where we can see event loop in action. As a side note, all code examples are located in the event loop example directory. So if you need to take a look, just grab the repo and you can find it there. And you should be familiar with our first example, since it's a async version of read file method. So we import read file from the FS module, and then we have a console log, started our task first. Then we have read file method where we pass the path, we pass the encoding, and then of course we have the callback. And then in the callback, I console log the first result, and then of course I have completed the first task. And then right after the read file, I have starting next task. And something really interesting. In a console, I can see that we first console log started the first task. Then I right away have starting the next task. And then, of course, once I'm done, once I get back my result, then, of course, I have hello, this is first text file, and, of course, completed first task. And again, the reason why is this happening, because read file is asynchronous. And we already know that event loop will offload this, in this case, to a file system. So we start reading the file. Notice like, okay, run this line of code, then offload this one, and only when I get back to the result, then run the callback. So when the file system responds with error or the data, then we invoke this one. All right. So we offload this task and we just keep on reading the code. That's why we have started the first task, starting the next one. So right away, go to the next task. And this one, this asynchronous one, well, we're just offloading. And then once the response comes back, whether it's an error, whether it's a success, only then we invoke the callback. Hopefully that is clear. Now, as far as this comment, I only added this one because we need to keep in mind that, of course, I'm just grabbing this code from the file, but the file is sitting in the folder. So if you were to run nodemon and then directly the file name, which is of course going to be in the event loop, the path won't match. So this path only matches because, of course, I have app.js. But if you'll try to run this code directly in this file, that's why it's not going to match, and you would need to go one level up. Now, my assumption is that you're running it the same as me, and you're running that with npm start. That's why I kept the path matching to the one in the app.js. Now, our next example, so let me clear my app.js. I can close the read file as well as package.json. And then the next one is set timeout. So select here everything and copy and paste in my app.js. I'll restart. And then I have two console logs. And the third one is in a set timeout. And this is pretty typical example for JavaScript loop as well. If you have taken JavaScript courses, which again, I assume you have, since you're watching the Node one, you probably remember this example. Where the gotcha here is following. Yeah, I have the console log first, then I have the second and third. And you think that since set timeout is set to 0, so since we're saying, yeah, call this callback function, but actually wait only 0 seconds, you'd think that the order would be first, second, and third, right? Well, wrong, because we have first, third, and second. Why? Well, because set timeout is asynchronous, correct? And what happens with asynchronous? Well, they get offloaded. So in this case, we run first, third, and then the second, because this one gets offloaded. Again, this one goes to the back of the line. And only when we're done with our immediate code, pretty much with our synchronous code, only then we invoke that callback. All right. Now, I also added these comments here where I have started operating system process and then completed and exited the operating system process. And the reason why I'm showing you that, because in next two examples, we'll do something a little bit different. So now I would want to go to set interval. And by the way, it's going to be a bit clearer if we run here node and then app.js. So let me stop this and I'll go with node and app.js. And you'll notice that we started the operating system process. And then the moment we're done with the code, that's it. We exit. Now, if we'll take a look at the set interval, you'll notice something really interesting. Where if I go with node and app.js, notice something interesting. And by the way, of course, I didn't copy and paste. So go to the third example and then just remove all this code and copy and paste. So that's my third example. And in here, I have the set interval. Now, again, yes, we'll have to run a few times node app.js. And now check it out. So what I see here is I will run first. So that's my console log. And then I have the set interval. And notice how we're not exiting the process here. So we started the process similarly to the second example. But if in the second example, we actually exited because we completed all our tasks, in this case, we're not doing that. Why? Well, because set interval is asynchronous. Now, the difference between the set timeout and set interval is the fact that set interval runs in those increments. In this case, of course, it is those 2 seconds. So every 2 seconds, the event loop is just gonna invoke that callback. Now, that's why we're not exiting. That's why we're still in the process and we can only exit the process if we kill it. So that would be Control and C, or there's some unexpected error. Otherwise, it will always stay alive. Now, again, keep in mind one thing where notice I will run first was first. Why? Well, because again, this is asynchronous. And I know I've said this before 20,000 times, but again, this is probably the core building block of Node. The fact that every time we have some asynchronous action, it's just going to be offloaded. And then when it's time, we invoke the callback. And our last example is a server. And again, I just wanted to showcase how the process stays alive. So I'll take all the code and copy and paste in app.js. Now I'll stop this one. So I'll stop the process and then we'll clear the console. And again, just to showcase how the process stays alive, I'm going to go with Node and app.js. And I'm doing that so you're not confused with NodeMon. And then check it out. So we have server listening on port 5000. And then every time the request comes in, well, we invoke this callback. And in our callback, we're simply console logging, request event, and then we send back the hello world. So now if I were to go to a localhost 5000, there it is. I have the response of hello world, and in a console, I'll see this request event. And check it out how, again, this process stays alive. Why? Well, because listen is asynchronous. And the moment we set it up, now event loop is just waiting for those requests to come in. And then once they come in, then of course we run our callback. Now, please don't confuse this callback with what we're responding, our request event. So this callback is just when we're setting up the server, because in here we can have the success or the error. So in our case, as you can see, everything went great. We have server listening on port 5000, but of course, there also might be an error. And this one, of course, just responds to that request event. But the whole point is with server.listen, we just say, hey, event loop, just keep listening for those incoming requests. And the moment show up, then respond to them appropriately. Hopefully it is clear. And of course, we can move on to our next topic. All right. And up next, I would want to talk about asynchronous patterns in Node.js. So if we remember when we were setting up the file system module, we covered how we have two flavors. We have the synchronous one and the asynchronous one. And while asynchronous one is great, since we're not blocking the event loop, the problem is that if we're using this callback approach, well, it gets messy pretty quickly, right? Because we're nesting one callback inside of the other one. So now in the following videos, I would want to show you the alternative that we'll use throughout the course and why, in my opinion, it is much cleaner syntax. And that's why, of course, we'll use it. And first, what I would want is just to kill everything here. And I'll start with the nodemon, since I'm done showing you the event loop. And we're just going to go with npm start, right? That was the proper one. And now I'll delete everything that I currently have not here. Sorry. So I'll leave this one, the async one. I would want to remove everything in the app.js. And now I just want to quickly show you the code that would block that event loop. Again, this is going to be the video where if you don't want to code along, you don't have to. You can just sit back and relax, and effectively you'll be in good shape. And again, we'll set up the server. Like I mentioned before already 20,000 times, don't worry about specific commands. We have the rest of the course where we'll be building servers. So trust me, you'll get sick of it. So we'll go with HTTP and require. And of course, we're looking for HTTP module. And then remember the methods create server and listen. So we go with const and we create the server that is HTTP and create server. We pass in callback. The callback takes two objects, request object and response object. So again, essentially request object is what is coming in and response object just represents what we're sending out. what essentially we are responding. And then I would want to listen on a port again. So I run server.listen, and then I'll pass in the port of 5000. And then, of course, we have that callback once the server is ready. And in here, we can just go with console log, and we'll simply say server is listening on port 5000. Server is listening, or just listening is fine. Listening on port, and then, of course, in my case, port is 5000. Let's set that up. So we should have this listening on port 5000. And then, of course, in my callback function, I would want to check for the URLs, because I would want to show you how even if we try to get a different resource, we're still blocked by other user if he or she is requesting some kind of resource where we have the blocking code. And don't worry, if this sounds like gibberish, you'll see what I mean in a second. So remember, on the request object, we could check for the URL. So effectively, you could check what is the resource that the user is requesting. So for example, homepage would be /, and then the about page would be / and about, and that is sitting in the property by the name of request and URL. So request is the object, and then URL is the property. So again, we'll do a quick and dirty way. We'll just say request URL is equal to a /. That means it's a homepage. And then we just need to go with res.end, and then we'll say homepage. Again, later we'll have way more sophisticated approach, but for now, this will do. And then we're checking for the about page. Okay, awesome. So this is going to be an about page. And then if there's a page that doesn't match any of the resources, then of course I'll just send back, I don't know, error page. I'm not going to set up the whole link, nothing like that. All right, we save it, and then this should send back about page. Awesome. And then of course in homepage, I can just respond with the homepage. So life is beautiful. Users can come here, and as a side note, multiple users I'm representing with these tabs. So imagine these are my users, and life is beautiful. We are requesting resources, and we're just going on about our day. Now, the problem is going to be if I go to about, and if I set up some kind of blocking code. Now, what would be a blocking code? Well, that could be a nested for loop. So I'm just going to go with blocking code, and then I'll add some exclamation points. And let's simply set up a for loop. Let's say I is equal to 0. And then let's say I is less than 1000. And yep, I plus plus. So every iteration will increase by 1. However, I'll set it up as a nested for loop. So copy and paste, and I'll just change these values to J. So J here and J here. And then let's just console log, and we'll say J and I. Again, doesn't really matter what we type there. Just say I and J. Now, $1 question. What do you think is going to happen? So if the user navigates to about, I mean, we can kind of see that this will take some time, right? Now, you would expect, though, that only the user who navigates here gets blocked. And you'd be wrong, because we'll also block the other suckers who are just trying to get to the homepage. So let me navigate here and check this out. So I run this one, and notice how we're loading. Now, the same thing happens here now and here. Okay. And only when we're done here, then these two can get the resource again. Now, of course, if I go to my project, I can see that in the console, I have all these values, right? Because I have this blocking code. I have the synchronous code that just takes a long time. And this is just a representation of why we prefer this asynchronous. Now, yes, at the moment, this is messy. And don't worry, in the next videos, we'll fix it. But this hopefully gives you an idea why you should always strive setting up your code asynchronously. Because what we've learned in the previous videos, if we do that, then those tasks are offloaded. And then only when the data is back, only when it's ready, then we invoke it. And that way we're not blocking the other users. Hopefully it is clear. And now, of course, let's take a look at some other patterns we can use. So we still get the benefits. So we're not blocking that event loop, but we also have a cleaner code where we don't have this nested callback mess. All right. And once we have covered why it's so important to use the asynchronous approach, now, of course, let's clean up our FA sync. So instead of using these nested callbacks, let's see a nicer pattern. And as a side note, if you want to see the code that we wrote in a previous video and the one we're about to write, then the files are located in two async patterns folder. So I'll close everything for now. And then back in app.js, I can remove it. Like I said, if you want to access that code, it is sitting in the two async patterns folder. And we'll simply start by recreating the read file setup, where I'm going to go with const, and I'm right away accessing that from the file system module, and I'll set it equal to require, of course, and then file system. All right, well, that's awesome. We know that it is asynchronous, so we need to set it up with 3 parameters. We go with read file, and then we would want to pass in path first. So again, since I'm in app.js, I'm going to be looking for the content, and then / and then first txt. The file we already created before, then we have encoding, so comma, and then again, we're going to go with UTF-8, and then last one is going to be that callback, where the first value is the error, and then the second one is the data that we're getting back. Okay, awesome. So once the file system responds, then of course we invoke this callback, and inside of that callback, we have our logic. So if there's going to be an error, for the time being, I will just return like so. And then if I have the data, I'll set it up as else. So I'll say here console log and data, of course. And we shouldn't be surprised if we see in a console, hello, this is a first text file, because we already covered the setup, right? So we pass in the path, we pass in the encoding, and then we set up the callback. Now the problem starts if we would want to perform multiple actions. If I want to read 2 files and then, for example, write one, correct? So what would be a better solution? Well, a better solution would be turning this into a promise. And then eventually we'll set up a sync await. Now, please keep in mind that the only reason why we'll type out the promise stuff is because I would want you to understand what is happening behind the scenes. But don't worry, throughout the course, we'll just stick with a sync and await syntax. And essentially, you won't have to worry about what is happening behind the scenes. But the first example, yes, I want you to understand everything in detail. So what we could do is create a new function, and we can just say const, and then I'll call this get text. Now this get text will take a path, since I would want to read 2 files, and then eventually write one as well, just like we did here. And of course, the goal here is to showcase how we can make the code in the file fsasync, at least that's how I called my file, much cleaner and more readable. So again, we pass in the path, and then what I would want to return from this function is a promise. So we go with return new promise, and then in the promise object, what we need to pass in is another callback function. So we pass in the callback function, and in here we pass in 2 more functions, one for resolve and then one for reject. And then once I have set up both of these parameters, now of course what I would want is to move the read file and place it inside of the promise one. Okay, so once we place it here, first of all, notice here how I'm passing in the path. So of course I can change this one around. So I can say path, and then the encoding stays the same as well as the callback. However, inside of the callback, once I have access to resolve and reject, what I could simply say that if there's an error, I will spit back the error. So say reject an error. And if everything goes great, now of course, let's go with a resolve, and then we'll pass in the data. And once we have this setup, what's really cool that now I can invoke get text, and this is going to return a promise. And then of course we can chain dot then and catch. So below the get text, I can go with get text. And of course we're looking for the path. So we still would need to use dot and then forward slash and then content, of course, and first txt. So that's the path. And then, like I said, we are returning a promise. So we can chain dot then. And of course, here I can have the result. And I'll just console log it for now. Result. And then I can also chain dot catch. And here I'm passing in the error. So again, we console log it. And we simply would want to see the error. I save it, and beautiful. Again, in a console, I have, hello, this is first text file. So I know that it worked. And also, if I change the path, so if I make my path incorrect, we should see in the console the error, where, of course, Node cannot find the file. So if that works, now, of course, we can take a look at how we can make it even cleaner by setting up async await. And once we have our initial setup, once we have turned this into a promise, technically we're not out of the woods. Because if I would want to perform again 2 file reads and then eventually write the file as well, and if I would want to do all of that asynchronously, it's still going to be pain just by using the promises. So what would be a solution? Well, since we're returning a promise, if I use async await, I can wait till promise is settled and then decide what I would want to do. And the way we set that one up is by creating a new function. Now, please keep one thing in mind where eventually throughout the course, those functions that I'm about to set up are going to be provided to us. So we'll just attach that async to the callback functions that are already provided us by the libraries. Okay. But in this example, I'll have to create one from the scratch. And again, the whole point is because I would want to create a function, a start function that I'm going to set it up as a synchronous function. And I would want to attach a wait. So I would only respond once the promise is settled. So in here I go const start, and that's my function, but I need to set it up right away as async because I would want to use my await keyword, correct? And then we simply go with const. And I know that, of course, I'm looking for the first file. And I'll just say first. And that one is equal to get text. And basically, I want to pass in the same thing here. Now, I do need to place this one in quotation marks. So my bad. I messed it up a little bit. Okay, I pass it in. And that should do it. Now, of course, what I'm missing here is await. So I had this await. And now only once the promise is resolved, then I'll get my response. So what I could do here is just comment these two, or you know what, this one I cannot comment out yet. Don't worry, we will eventually. This one I can comment out and then maybe move this below. Okay, so you don't think that I'm running this code. And since I have my function now, of course, I would need to invoke it. So invoke start and check it out. Now, of course, I don't have the error, which is a good sign, I guess. And then we'll simply go with log and then first. And notice the difference. Where previously, when we were setting up the callbacks, we had to nest everything. Now I'm waiting for this promise to be resolved. And only once it's resolved, then of course, I can do something with the value. Now, every time we have this async await approach, what we would want is to wrap this in the try catch block. So if something goes wrong, then we have at least a little bit of control over it. So I'll set up try catch block, and then I'll set up my first await, and eventually we'll add here more. And then in the error, I'll simply go with console log, and we'll console log the error. And let's just save that one. So now we have nice try and catch block. And by the way, sorry, I deleted it. We'll still take a look at the first one. And then if we change the path, then of course we'll get an error. Okay, so that's good. Now I have my start function. It is asynchronous. I'm waiting for the promises to resolve. They're all wrapped in try catch block. So what's next? Well, if you remember in here, what were the actions that we were doing? Well, we read two files, correct? And then we wrote one. Okay, so let's try that one with this new approach, where essentially I have first, so just copy and paste, and then I'll look for the second file. Remember, we should have that in the content. So this is going to be the second one, second over here. And then I would want to write the file. Now, of course, you could say, well, the problem here is going to be that I'll have to write a new wrapping function to set it up as a promise. Because yes, we can, of course, read the file, but the functionality for the write file, again, we would need to wrap it. Don't worry, there's a way how we can get this actually out of the node. First, I would just want to showcase how much cleaner this already is, where I can just wait for first, second, like so, and now notice in the console, hello, this is the first text, and hello, this is the second file. Again, I fully understand that you're looking at this wrapper function, and you're like, well, this definitely doesn't look that much cleaner than this one. Don't worry, there's a way for us to get those functions in a way that they're already returning a promise. What I would want you to focus on is this code. What I would want you to understand that this definitely is much cleaner than what we have here. We read a file and then we set up another nested callback and another nested callback, and hopefully you get the gist. Waiting for these promises to resolve is definitely a cleaner and more readable approach. All right, so this works. We have our start function. It is asynchronous. We're waiting for promises to resolve, and we can see that it is already much cleaner. How we can set up this code without the wrapping function? Well, what's really cool that in Node, there is a module by the name of util. And we'll just go here, const, and we'll assign it to a variable. And we'll just be looking for require, of course, since we would want to import the module. And again, the name is util. And then inside of this module, we have a method by the name of promisify. And with the use of this function, we can take our read file, which of course was looking for the callback, and turn it into the function that returns a promise. And again, this is oversimplified version of what is happening there, but hopefully you understand that as a result, we'll get again this promise back. Now, the way we'll set that up, of course, we have a read file here already, so I cannot use the same name. That's why I'll go with read file, and we'll call this promise. And that one is equal to util. That is, of course, my module dot, and then notice the function promisify, and then we pass in that read file function. So now I have my promise one. So now what I could do is, first of all, comment this out and move it down. Again, so it stays for your reference, but it doesn't compromise my view. And of course, now I'll have the error because, well, get text is not defined. That's fine, don't worry. And I'll copy and paste. And since I also would want to write a new file, I will get from the file system one the write file function, and then I'll do the same thing, where in this case it's going to be called write file promise, and then we pass in write file. And of course, now instead of calling get text, what I'm going to do is go with write file, or I'm sorry, in this case, we're going for read file promise. And then keep in mind one thing, where this is not a get text one. So we're still looking for the path as well as the encoding. That's why I'll copy and paste. And then the second argument we pass in is the encoding. And again, our functionality shouldn't change, where I should see in the console the results from the first txt. Now, of course, I would want to do the same thing with the second one. So have read file promise, second txt. Again, we have to pass in the encoding, otherwise we'll get the buffer back. So copy this and paste. And again, if we console log it, there it is. We have, hello, this is first text file, and this is the second one. And since in the line 4, we passed in write file into promisify. Of course, what we could also do is right away write the file. So I can go with await, and I'm simply not assigning this to a variable because, well, I'm getting back undefined there as far as data. And I'm just going to go with await, write file promise, and the same spiel. We pass in first the path. And in this case, of course, if the file is not there, Node will create one. And the name will be result. And I'll just call this mine grenade and then txt. And then the second one is data. So for that one, I'll set up my template string. And I'll just say this is awesome. Awesome. And then let's set up the colon, and then we'll access both first as well as the second one. So we'll interpolate both of them. Second. And then once we save, if we take a look at the content, there it is. Now we have the mine grenade one, correct? Now there's probably one where I was testing. Yep, there's one where I was testing, so I'll remove this one. But if I take a look at the txt one, then of course I'll have this is awesome. Hello, this is first text file, and then I have the second one. Now, what's even more cool, that technically we can even skip this part as well. Again, I'll leave this one for your reference. But if you go to require, and then you require, of course, file system module. But if you add dot promises, what do you think is going to return? Well, effectively the same thing. So now, of course, I just need to change the name from read file promise and write file promise back to read file and write file, since those are the two functions that I'm importing, and they will right away return promises. And again, we save, and remember that by default, we're just overriding stuff. So if I were to go and add a third argument, my options one, and if I'm just going to say flag and I'll set it equal to append, once we save, well, now we have this is awesome. Repeat it one more time. Again, just to showcase that our functionality still works. I fully understand that there was a little detour where we created our own wrapper function, and then we covered how we would consume promises. But hopefully this helps you understand that this approach is definitely way better. So it is more readable. It is more easier to wrap your head around. And that's why for the remainder of the course, we'll stick with this one. Again, some things will be provided to us by default. So libraries will provide the functions that return promises. Will right away have the callback functions that we'll just set up as async, and hopefully you get the gist. So a lot of things will be given to us, but the core functionality won't change, where instead of using callbacks and nesting them inside of the other callbacks and nesting more and more and more, we'll set up everything with async await, because the syntax is cleaner and way easier to read. Excellent. Once we have covered async patterns we're going to use throughout the course, now let's talk about events in Node.js. When working on browser JavaScript apps, a big part of our work is to handle events. For example, user clicks a button, and of course, in our program, we handle that. User hovers over the link, and again, same deal. In our program, we are handling that. And hopefully you get the gist. Essentially, as our program executes, at least in part, it is controlled by events. Of course, depending on a program, but it's safe to say that in browser app, those events are mostly external. Now, that style of programming is actually called event-driven programming. And effectively, it's just that, a style in which the flow of the program is at least in part determined by the events that occur as the program executes. Now, it's easier to imagine that, of course, when you have a GUI, right? The graphical interface, just like the button and links example I just mentioned. But what about server side? Is it also possible? And of course, the answer is yes. In fact, event-driven programming is used heavily in Node.js. And in the following videos, we'll see some of the examples of it. And basically, the idea is following. We listen for specific events and register functions that will execute in response to those events. So once our event takes place, callback function fires, just like in our imaginary button example. Now, before we continue, let me stress something. Our first examples are going to be basic and even somewhat silly, but don't let that fool you. Many built-in modules in Node.js do use events under the hood, and therefore making events and event-driven programming a big part of Node.js. All right, and once we have covered general concepts behind events as well as event-driven programming, now let's set up our own events in Node. And the way we do that, we come up with a variable, and typically this name is event emitter, because what we're getting back is the class, and we require the events module. So we require events module, and we assign it to a variable, which essentially is a class. And again, a common practice is calling this event emitter. And at this point, you have two options. If you want to create something custom, you'll need to extend the class, or if you simply want to emit an event as well as listen for it, then you can just create the instance. So we'll go with the second route. We'll go with const and then whatever name you would want. In my case, I'm just going to call this custom emitter, like so. And I'll assign it to new emitter, so event emitter, or however you call this variable, and we just need to invoke it. So now we have the instance of our class. So essentially we have the object. Now there are many methods in this object. However, two that we're interested in most are on and emit. So on will listen for specific event, and then emit, of course, will emit that event. And the way we set it up, we go with custom emitter or whatever name you used, and then we go with on. And at the very basic setup in the on method, we just pass in the string where we say the name of the event. Now, in my case, I'll name my one response. And then, of course, once I have subscribed to it, I also would want to pass in the callback function. So essentially, when this event takes place, well, then I would want to do something. And in my case, I'll just go with console log and we'll simply say data received. However, I'll place this one in the template strings and you'll see in a second why. So we'll go with data received, and then eventually there's going to be some more data. And of course, once we have subscribed to this specific event, now I would want to emit it. And the way we do that, we just go with custom emitter. And then of course, the method is, surprise, surprise, emit. And of course, at this point, these strings need to match. So if I'm emitting the response event, I just say here response. And what you'll see in the console is wherever you have in a callback. So of course, in my case, I have console log data received. And then once I run it, I have data received in a console. So that's the most basic setup when it comes to events. Again, we create an instance from the class that we get back from the events module. And then we have two methods. We have on method as well as the emit method. And then in the on method, we pass in a string. So that's going to be the name of the event as well as the callback function. So once this event takes place, then of course we would want to do something. And in our case, we'll just console log data received. And then once we have subscribed to this event, then of course we need to emit it. And the way we do that, we just go with whatever the name is, in my case, custom emitter, then emit method, and then we pass in the same string that we're listening for. In our case, of course, response. And then the moment we do that, we of course have whatever is in the callback function, which in our case, of course, is just a simple log data received. All right. And once we have covered the basic setup, now let me show you some things that I would want you to be aware of. First, we can have as many methods we would want. So for example, we have the same event. We have here response, correct? And we are omitting it. So nothing stops me here. Just copy and paste and listen for the same event, which of course in our case is this response, and then do some other logic in my callback. Again, in my case, it's just going to be simple. different console log. So I'm going to say some other logic here. And I'm not going to copy and paste the same function 20,000 times just to prove my point, but hopefully you understand that yes, we can emit our event, and then yes, also we can have as many functions we would want here that are listening for that event and do some other logic. So that's point number one. Point number two that I would like to make is the fact that this order matters. So we first listen for event and then we emit it. So for example, if I will place my emit above the second function or above both of the functions, what you'll notice that I have nothing in a console. Why? Well, because I first emit the event and only then I listen for it. As you can see, that doesn't make sense. So first we would want to listen for the event and only then we would emit it. So in this case, notice I don't have this some other logic goes in here because I listen for response and then I right away emit the response. And then again, I listen for the response, but I already emitted the event, correct? So it doesn't make sense to listen for the event once it has been already emitted. So that's the point number two. And then thirdly, I would also want to showcase that we can pass the arguments when we're emitting the event. So for example, I go here with my emit, I pass in the name, which is of course response, and then I can pass in more arguments. For example, here I'll go John and then the ID number 34. So string and a number. And then in my callback function, I can access those arguments as parameters, just like normal functions. So in this case, I'll call them name and ID. And simply in my console log, I'll say name. And the second one will be with ID. And then whatever is that ID. Now I'll add here data received user and then save it. And it's no surprise that in a console, I see data received user John with ID 34. Now in the second function, as you can see, I wasn't looking for those arguments. I just don't have access to the arguments because I don't have the parameters, but it's not like everything broke just because in the event I passed in the arguments. And lastly, I would just want to reiterate the point that even though you might not write your own events, events are a core building block of Node. And effectively, as you're building and writing out the code for your Node application, you are using those events at the end of the day anyway, because a lot of built-in modules rely on them. And as a quick side note, if you'd like to see the code that we wrote in previous two lectures, you can just navigate to 13 event emitter. And in order to show you that, I'll quickly set up a server. And again, the code for this one you can find at 14 and then request event. So I'll copy all the contents from the file and then just copy and paste. And notice something interesting where again, yes, we're getting the HTTP module. And remember the setup that we have used so far, where we go with HTTP create server, and then we pass in this callback function. And then of course, this callback function will be invoked every time someone visits our server. So every time the request comes in. Now there's another way how we can set it up by using event emitter API. So we still create a server, we go with HTTP and then create server function. But instead of passing in the callback function, like we did previously, server has the method on. Does that ring a bell? Remember our previous example? We had our own instance and it had the method of on, correct? So the same goes for server. So server has the method on and we listen for request event. And when that request comes in, then of course, again, we have this callback function that handles it. So behind the scenes, server emits the request event. And then of course, we can listen for it. We can subscribe to it, listen for it, or respond to it, however you'd want to call it. And the way we do that, we go with server on, and then this is a specific name because of course it emits that specific name behind the scenes. So make sure that it is a request and then the same spiel. Now, how do I know that? Well, if we go to node documentation and if we look for HTTP, we keep on scrolling, eventually we'll hit the server. And over here, I can see that it has a class. Okay, that's a good start. And then what do you see here? Well, I see the event, right? And what is the event? Well, the name is request. So that's how I know that my server, the instance that I create, has the ability to listen for request events. And if you want to dig deeper, you can just click on a server. You notice that it extends the net server. And if we keep on digging, check it out. So this one extends what? It extends the event emitter. So hopefully that makes it clear that even though you might not be setting up events on your own, a bunch of built-in modules rely heavily on this concept of events. All right. And up next, we have streams in Node.js. And at its simplest, streams are used to read or write sequentially. Basically, when we have to handle and manipulate streaming data, for example, continuous source or a big file, streams come in real handy. In Node, there are 4 different types of streams. We have writable, used to write data sequentially. Then we have readable, used to read data sequentially. Duplex, used to both read and write data sequentially. And also transform, where data can be modified when writing or reading. Just like with events, many built-in modules in Node implement streaming interface. And what's also interesting, streams extend event emitters class, which simply means that we can use events like data and end on streams. Since streams are somewhat of an advanced topic in Node, I'll try to keep it short and sweet, mostly by showing you examples of streams, and hopefully that way you get the main idea without being overwhelmed. All right, and once we know the theory behind the streams, now let's take a look at the practical example. And a very good use case is using streams when we are reading files, because we need to understand one thing, where when we use the sync or asynchronous approach, what happens, we're reading the whole file. And of course, in our example, we were setting this equal to a variable, correct? But if we have a big file, well, first of all, you're just using all that memory. And second, as the file size gets bigger and bigger and bigger, eventually the variable is not going to be good enough. You will get an error that, the size is too big and you cannot place everything in the string. So what would be a solution? Well, solution would be read stream option. And the way we'll set this up, I'm going to start app.js from the scratch. But if you take a look at the repo, you'll notice this 15, create big file. So previously, when we were working with files, I just had some small files, right? So I had the first txt, blah, 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 result, and whatever. Now, before we set up the read stream, I would want to create a big file. Again, this is optional. You don't have to do that. But in my case, in order to show you how the streams work, yes, I'll have to set up a big file. And first, I'll remove it because, of course, I already have it since I was testing it. And now I'll stop my server. And of course, in my case, I'll run 15, the create big file JS. If you want to set it on your own, and if you don't want to use the repo, you can just get the right file sync from the FS module. And then notice I have the loop where I believe I have here 10,000. And then every iteration, I just write a big txt. Of course, I have the flag append, and then I'm just adding hello world and starting a new line. So if I'll run node, and then of course, I'm going to go with my file name, which is 15, then hyphen create big file and JS, like so. Then in the content, I should have this big file. And once I have my big file, I'll go back to app.js and I'll use my npm start, since of course I have nodemon in place. And then let's go with const. Now, I'm not going to show you how the setup would look like with file sync or the asynchronous one. Again, hopefully you understand that the setup would be exactly the same like we have in 10 and 11, where we had the FA sync and FA async. And now, of course, let's just go with the stream option. So the method name is create read stream, and we require that from the FS module, like so. And then we create a new variable, and in my case, I'll call this stream, and we invoke the create read stream. And the only thing by default we need to pass in is the path. So, of course, in my case, I'm going to go with content and then /. And since I just created that text file, the big one, of course, I'm going to go with big txt. And now remember the good old friends events. Well, once we create this instance, we actually have access to them. And the ones that we're going to use is going to be data and error. So we can go with stream and then on. Again, remember the event syntax. And then the event that you would want to listen for is a data. And then we have our callback function. And again, it is a parameter, so we can call it whatever we would want. But in my case, I'm going to go with result. And let's just console log the result, like so. And what you'll notice is that we have 64 kilobytes here. That's our first console log. Then we have another one for 64 kilobytes. And the reason why I know that is because by default, that's the size we're getting. And then we're getting the reminder. Now, just to prove my point, I'm going to go to my folder and I'm going to look for my content. And then in there, if you take a look, the big text file we created is 169 kilobytes. So as you can see, now we're reading data in chunks. And by default, that chunk is 64 kilobytes. And every time we console log, we see that we have 64, 64, and eventually we have the remainder. So instead of reading everything and placing that in a variable, we're doing that in chunks. And as you can see, we're using the event, and the event is data. And in order to hammer this home, why don't we take a look at the docs? So first, I'm going to look for my file system, and then let's look for our create read stream. So we go here. As we can see, we have this class, read stream. And then on this class, we have these three ones. We have close, open, and ready. And as a side note, we'll use this one a little bit later as well, the open one. So keep an eye on this one. And then as far as the read stream, well, as you can see, it is created when we go with create read stream and invoke it, right? So I got the create read stream. That's my function. I just passed in the path and I invoked it. And in turn, that returns the read stream, right? Then actual read stream extends from stream.readable. So right away, I have these events. I have close, open, and ready. And like I said, we'll use this open a little bit later. Now, since it is extending from the stream, check it out. Now, of course, I have the data one, right? So this is a chunk of data. And as you can see, every time we are getting that data, we can do something with it. Now, at the moment, we're just console logging. It's very simple. But eventually, as you can already imagine, we can do way more useful things than that. Beautiful. Once we understand the basics, now let's take a look at some additional info. Like I said, by default, the size of the buffer is going to be 64 kilobytes. However, we can also control it. And the way we do that is by passing in the object when we're setting up create read stream. So first argument is going to be the path, which again, in my case, is going to be that big text file that I created using my file, using my for loop. And then I can pass in the options object. And in there, the property that you're looking for, the property that controls the size of the buffer, has the name of high watermark. So for example, if I go with 90,000 here, then of course you'll see that I'll have two console logs, one for 90 kilobytes, and the second one will be remainder. Again, keep in mind that our file size is 169 kilobytes. That's number one. Number two, we can right away set up the encoding as well. So I go with comma, and then the property name is encoding. And again, we'll set it up equal to UTF-8, like so. And then you'll see in the console, of course, the hello worlds. Why? Well, because that is the content coming from the file. And lastly, I also would want to mention that we have the error event as well. So if I go with stream and then on, and we're checking for the error, and as always, we can do something once that error happens. So that's our callback function. And in this case, I'll just access the error property and I'll console log the error. So I'll say here error. And the way we check that one out is by providing wrong path. So in my case, I'm just going to add 2 dots. And then once I save, check it out. In the console, I'll have the error where it tells me that no such file or directory. All right. And now let's take a look at the practical example when streams come in handy. Now, again, this is going to be one of those videos where you don't have to code along. You can just sit back and relax and see how I struggle. And first, what I would want is to make it even a bigger file. So remember the 15, create big file. I believe I had 10 iterations, right? So I'm going to add one more, meaning I'll add one more 0. I'll stop my server right now. Again, this is optional. You don't have to do that. And I'll remove the big file like so. And then I'll run one more time the file with node. And then, of course, this file is going to be way bigger. So let me navigate to my folder just to showcase that. And I'm looking for content. And now the big file is 1.8 megs. Now, once I have the big file, I'll go with npm start. At the moment, I just have the stream example. But if you want to see the whole code, just take a look at the file number 17. And notice again, we're creating a HTTP server, and I'm just using the read file sync method. I'm looking for big txt. The encoding is UTF-8. And then I just place my variable, my text one, into res.end method. And effectively, I'm just sending my big text file. And let me restart the server here. So let me go with npm start right now. So let me select everything from this file and copy and paste. And now if we navigate to localhost 5000, we should see a bunch of hello worlds. Now, the problem with this setup is following, where if I go to developer tools and if I take a look at the network and if I refresh, yep, this request was successful. Take a look at the size. Do you think it is the smartest thing to send these type of files over the wire? And of course, this is just going to make it very difficult to all your users because you're just sending large chunks of data. Effectively, I'm sending the whole file. And more specifically, if I click, check it out. So I have the request URL. Okay, that is good. The method is get. Now, as you can see, the content length is my 1.8 megs, right? And you'll see in a second that once we refactor this to read stream method, that we're sending data in the chunks. And again, the best way to see that is by looking at the headers, where at the moment I can see the content length, and that one is at 1.8 megs. But once we refactor that, the setup is going to be different. So at the moment, I have this text. I'm accessing that by read file sync. So I'll comment this out, and let's set it up with our create read stream. So I'll go with const, and I'll call this file stream. And this is going to be equal to fs, and then create read stream. Now I'll use the same address. So I'll use the same path, and then I'll use the same encoding as well. So let's go with UTF-8. Okay, awesome. And once we set up the stream, remember we have access to 2 events, file stream on, and of course I'm going to be looking for the open, and I'll have my callback function, and we'll set that functionality up in a second. And the second one, of course, is the error. So I'll go with file stream and then on. And again, we're looking for the event by the name of error. And then in our callback function, we can access the error, and I'll simply pass it in my response. So if there is an error, I'll just grab the error from my parameter and pass it in. Now, as far as the open here, instead of setting it equal to, instead of going res.end and then text, file stream also have the pipe method. So we can go with file stream and then pipe. And what the pipe is doing, it is pushing from the read stream into write stream. So you can imagine that if we can read data in chunks, we can also write data in chunks. And what happens under the hood, a response object can be set up as a writable stream. So we have our file stream, so that's our read stream. We have method of pipe, so we're piping this into a writable stream. And now, of course, I'll pass in my response object. And if we go back to the browser and if we'll refresh, now notice something interesting. Yeah, still same request, right? To localhost 5000, still same size. But if I take a look at the headers, now I can see that my response headers are chunked. So instead of sending our file back in one large instance, we're sending it back in chunks. Awesome. Congrats on completing section number 3, Node Fundamentals. And hopefully after watching the section, you have a good general understanding of how Node works. And now that we're big shots, let's apply that knowledge and build some servers, shall we? And we're going to start section 4 with the general info of how the web works. More specifically, how we exchange data on the web. And we're going to do that with the help of a few slides. Now, if you're one of the people who's already reached a daily slide limit, I hear you. Once we're done with these suckers, I promise we'll mostly actually write code for the remainder of the course. I do believe, though, that before we build an actual web server, it's crucial for us to understand how it works under the hood. And that way we'll have clearer understanding of what tasks need to be done. If something is iffy, you can always go back to the slides. You already know where they're located. And also, as we're going to be progressing with the course, from time to time, I will swing back to them when I'll need to emphasize a specific point. With that said, let's talk about how we exchange data on the web. It's safe to say that if you're watching this video, you know how to use a web browser. But under the hood, the way it works, every time we open up a browser and we type the URL, so the web address, we're actually performing a request. And we are performing a request to the server that is responsible serving those resources. So for example, when you look for CNN.com, you're looking for the server that has those resources, and then that server sends you back the response. And the same works with YouTube, the same works with johnsmilk.com or whatever. So you just pick a resource, you say, hey, can I get this data? And then server who is responsible for those resources just sends you back the response. Now that is done using HTTP protocol, and that's why these ones are called HTTP messages. So the user sends the HTTP request message, and then the server sends the HTTP response message. And that's how we exchange data on the web. And for the remainder of the course, we'll be responsible for building such web server using Node and more specifically Express. Now I'll talk about it why we use Express as well as show you a few examples later on in the course. But for now, just remember that yes, we'll use Node, but in order to make our lives easier, we'll use the framework by the name of Express.js. And lastly, I would just want to mention that even though name server definitely sounds way cooler than the computer, at the end of the day, they're just computers whose job is to always make that resource available. So yes, those are computers. And yes, there are some differences. For example, they most likely don't have the graphical interface or the GUI. And also, they're probably much bigger than your laptop. But at the end of the day, they are computers whose job is to always make sure that that resource is available. Because imagine if you would have a server that only works from 8 to 5. So if you go to your website at, I don't know, 6 o'clock at night, you cannot access the resource. Probably that's not the service that you would pick. So next time when someone asks you if it rains, does the cloud still work? You know what to answer. Because at the end of the day, when we talk about cloud, cloud is just a bunch of these servers, bunch of these computers connected together. Beautiful. And once we have a general understanding how data is exchanged on a web, let's also cover how HTTP messages are structured. Please keep in mind that since it's going to be a big part of our job, we'll come back to this particular slide more than once. So if you're iffy about something, just please be patient and I'll answer all of your questions as we move along with the course. With that said, the general structure for both messages is similar. They both have a start line. They both have optional headers, a blank line that indicates that all the meta info has been sent, and effectively headers are that meta info as well as optional body. And before we continue, again, let me stress something. So request messages are what the user is sending. So for example, if you open up the browser to search the web, or that could be your web application. Because remember, with web applications, we also can make HTTP requests, correct? And then response is going to be our responsibility. So we'll have to set up a proper server that sends a correct response. And in general, when we talk about the request message in the start line, there's going to be a method, then the URL, as well as the HTTP version. Now, we are mostly going to be interested in these two things, in the method as well as the URL. Now, there's going to be a separate slide about the methods as well. And don't worry, we'll cover that in greater detail once we cover them with actual code examples. So I'll come back to that slide. Just understand the general idea that when we talk about methods, effectively we're communicating what we would want to do. So for example, if I want to get the resource, I'm going to set it up as a get request. Now, if I want to add the resource, then of course this is going to be a post request. And then of course you can read the rest. Now, why I'm displaying here this get, because that is the default request that the browser performs. Since when we open up the browser, we want to get some kind of resource, correct? That's why we're performing a get request. And the URL is just the address. And that could be, for example, johnsmilk.com, or that could be, I don't know, ESPN/basketball. Both of them are just a web addresses. Now, headers is essentially optional, where this is a meta information about our request. And just to give you a general idea how the headers would look like, they would look something like this. So it is a key value pairs. Now, don't freak out. As you know, when you search the web, you don't need to add them manually. And the same is going to be with our server. A lot of it is going to be taken care of. But yes, some things we'll have to add on our own. Basically, this is going to be information about our message. And then we also have optional body. So when the user is requesting something, if you just want the resource, there is no body. There's nothing basically what to send. However, if we would want to add a resource onto the server, yes, then you're expected to provide that data. And it's also called payload. So again, I might use them interchangeably. So that's the general structure of the request message. We have the start line, we have the headers, that is the information about our message, as well as the blank line, which just indicates that we're done with the meta information, and optional body, which we'll use from time to time. And now, of course, we need to talk about the response message. So response message is what we are going to be creating. Again, most of it will be done for us. But some parts, yes, we'll have to do it manually, and it's going to be our responsibility. So the start line has the HTTP version, which most likely is going to be 1.1. Then we have a status code and status text. Now, when it comes to status code, it just signals what is the result of the request. So, for example, notice here this 200, that means that request was successful. So that's what we're sending back. And yes, there's quite a few of those codes. And as we move along with the course, of course, we will cover them. But please, please, please don't rush over to the search engine and start memorizing the status codes. Pretty much as we're going to be building the application, I'll tell you which code means what. And for example, 400 means that there was some kind of request error. So the user was trying to request some kind of resource. And with 400, there was a request error. Now, for example, the code 404 means that the resource is not found. So when I'm sending back the message, I'm like, hey, listen, here's the status code for the message. If you were successful, here's 200. If there was an error, for example, you get a 400. If the request is unauthorized, then you can get 401, and hopefully you get the gist. And yes, of course, as we're progressing, we will cover more status code. Then again, we have the headers, where basically we provide info about our message, our response message. And again, like I said, you won't have to type everything line by line, but effectively it is a setup of key value pairs. And the ones that I would like to mention are these ones. Notice this content type. We have text HTML. That is when we're sending back the HTML, but also our second option is going to be sending back the data. So hopefully you're aware that when you're building a web application, when we communicate with API, most of the time we're getting back the JSON data, because over the web, effectively, we just send over the string. So if, for example, I have some kind of array, we transfer this into application JSON, and I clearly indicate that in my headers, where I say that, no, I'm not sending text and HTML. I'm actually sending a application JSON. And then that application who is requesting the web application knows that, hey, from the server, I'm getting a content type, which is application JSON. So for example, in that case, I could send back here this array with a bunch of these objects. And just to give you a real world taste, why don't we do this? Open up a new browser tab, and I'm simply going to Course API because I think there's going to be less data, so there's going to be less clutter. So go to course-API here, and then you can either pick the slides or you can just look at the homepage. And if you inspect and if you look in the browser tabs, you'll find a network. And very useful one is this one where we can just look for all the requests. We refresh and then check it out. So these are the requests that browser performed, and I'll talk about it a bit later, why there's also this style CSS. In fact, that's going to be one of our first examples, but take a look at this one. So I have this course API and then /. And if you remember when we were building our original server, what I said that if we have this /, that just means homepage. So if we're just navigating to courseapi.com, and that is our homepage, we simply add this /. Now, of course, in the browser, that's automatically added, but that's why when we're setting up the server, one of the cases is going to be if the user navigates to the homepage, then we simply look for the /. So if, for example, you go to the slides, you'll notice that, in this case, I would have to refresh. Notice here I have the Course API /slides. So that is already a page in my website, correct? So I have the homepage, Course API, and then I have the slides page where I have the slides. And if you take a look, if you click on it, notice all the useful data that we get over here. So for example, this is going to be our request URL, which is going to be again courseapi.com. So that tells me Well, what the browser is trying to get. Then check it out. The method. Why it's get? Because that is default in the browsers. Every time you open up the browser and search something, then of course you'll be performing a get request. Now check it out this one. The status code. It is 200. Why? Because everything is successful. Because servers send back the data. Then we have this remote address. And basically that is the IP address for my server. As well as notice this colon 443. And we'll come back to this one when we set up our own server. Because if you remember, we were always setting up the 5000. So you're probably wondering, well, what is this 443? And don't worry, again, we'll cover that one once we set up our first server. And then again, we have response headers, for example, and we also have the request headers. So as you can see, using this network type, we can actually find a bunch of useful information. Now, notice here in the second set of tabs, I can see this response and preview. So if you take a look at the preview, this is going to be basically my site. And also I can see the response. So as you can see, pretty much sending back the HTML. So I'm sending back the website. So you go into the browser, you request a resource. By default, it is a GET request. And then in that body, when the server sends it back, this is what we get back. So we get back the site. So hopefully this gives you a clear understanding of how the HTTP messages are structured. And now let's dive into creating our own server. Awesome. Once we're done with the slides, now let's start setting up our server. And in order to follow along with the course, you'll need to have a starter project. And you can get it if you navigate to my site. Again, the URL is johnsmilga.com. So navigate there in the projects or in the homepage, look for Node Express tutorial project. In the homepage is going to be at the bottom in the latest projects. If you cannot find it there, then look for all projects page or simply projects page, then filter for Node in order to save some time. And then, like I already previously mentioned, any of these links will get you to the repo and then bravely get the repo. In my case, I'm going to clone it. So I'll copy the URL. I'll bump up the sound size in my terminal, navigate to the desktop, git clone here, and then I'm going to get the repo. And then once the project is on my machine, I'm just going to drag and drop. And then the first thing that I would suggest doing is removing the remote URL. And you can simply do that by just wiping out the Git folder. So that way, if you ever do decide to push this up to the GitHub, you won't have some dumb permission errors. So I'm just going to open up the integrated terminal. Now, in my case, I'm not going to run the command, but if you're on Mac, I suggest running rm, then -rf, and then git. Now, if you are on Windows, some students have suggested these two commands. Now, I haven't tested them yet, but some people have replied to my tweet that yes, they do work. And if you want to see the whole tweet, just navigate to my Twitter. The handle is John_Smilga. And then, as you can see here, is the Mac command. And for Windows, I have these two. So run this command, and then in next video, I'll give you a brief overview of the repo. All right. And before we get busy, why don't I give you a brief overview of the repo? And if you take a look at the first project, this should look very, very familiar because essentially this is all the code we have written so far. Everything starting with our most basic application. And then, of course, we also have our last one, our HTTP streams example. So hopefully that is clear. And if you ever need to jog your memory, essentially this is just here for your reference. And then from now on, we'll work in folder number 2 by the name of